just works. It just works. Good morning, everybody. Oh no, did I change this thing wrong? Hold up. Let's make sure that I did this right. Wow, what a weekend. Last night I managed to go see Comet Neowise. Just caught a glimpse of it. Alright, we're in just chatting. What a weekend. Okay, there we go. Just had to finish updating all that stream info. Chatterino's up. Oh my god. Check these levels here. Hope that's alright. Yeah, should be good. Alright, let's get some things organized here so that we can start doing microscopy. Yeah, this is trash. Yeah, alright. So yesterday I went out to a few different local ponds and I got 3 new jars of water. So I have jar number 1. This comes from a pond called Lily Pond, but there's no lilies in it, just lots and lots of algae. Now this algae is a very fine Spirogyra algae. You can probably not even make it out there. Anyway, I also grabbed a fair amount of muck from the bottom of that pond. So hopefully we can grab a little slide of that muck as well. Maybe find some cool worms or who knows what else is just living in that muck at the bottom. Then I went back to an old pond that I haven't visited in a while. This was a pond that seemed to have gone through some kind of ecological collapse after they treated it or did something to the water. It was a municipal pond, so it could have been anything. I went back. The water level hasn't gone back down, but I see cyclops and ostracods swimming around in here. So it looks like the ecosystem is starting to recover. So we'll take a look at this sample as well. And then I stopped at a third location and I got another sample. And this is an interesting little piece that I wanted to look at. It's going to be difficult to get a sample of it, but there's almost like this jelly-like substance that's clinging to some of these strands of algae. It's strange. Like algae strands. I'm going to draw a picture of it because It's difficult to describe. It's hard to say. So like, I don't know if you can see it in the picture at all if it comes through, but yeah, so like there's the main strand of algae here, and then the little pieces of algae that come off of it going down here. And then at the ends of these pieces of algae is this wispy, cloudy, I don't know how to describe it. It almost, like I said, it looks like a jelly, like a freshwater jelly, except it's more of a residual buildup around the edges of these algae. So I'm not sure. We'll look at it in the microscope and find out what it is. That should be fun. I had a brush with celebrity. Academic PZ Myers tweeted spider pics at me yesterday, so that was cool. Let's get all of our little boxes open here. Got my book. Just a second here. Where's my dry samples? Come back here. There it is. This here, one of the best sounds in Twitch. This is just for a focus slide here. There we go. Let's get this camera attachment on there. Oh, what's this cable stuck on down here? Come on out. There it is. There it is. There it is. There we go. All right, while I create a slide, I'll play some footage. How's that? There's a Daphnia. Daphnia are very pretty little creatures. Daphnia are freshwater animals. This one is pregnant. So get a look at it moving. Can you see its baby inside? Again, let's look a little closer and in a transparency. Can you see the baby inside? In this video, you can actually see 2 hearts beating. we've got in this footage. Hey Ziku, good morning. Look, oh, that's not how that works. Here it is. Oh, right. There's a heart and there's a heart. So let me just put a circle around those real quick. That one. And this one. How you doing, Zico? Good morning. Alright, watch these two spaces that I've just highlighted. And you'll see heartbeat. Alright, there we go. Excuse me. Zeke, I'm doing real well. I just woke up, as evidenced by a cup of coffee. I am good. Yeah, I just spent some time this weekend traveling to a few different ponds, freshwater ponds in my area to collect some new jars of water. So we've got 3 samples that we're going to look through this morning. First sample, the greenest one yet, it comes from a pond called Lily Pond. No lilies in Lily Pond, but there's lots of muck and Spirogyra algae in this jar. And hopefully we'll find Daphnia or copepod, or definitely going to see gastrotrick, all kinds of neat stuff in here. I went to another pond and I just collected an interesting sample, a curiosity from this one. It's more of a freshwater sample, not quite a lot of algae, but there's an interesting growth appearing at the ends of these algae strands, and I really want to investigate it. It looks like a freshwater jelly. I know that's not the case, but something is coalescing and growing at the ends of these algae strands, so we're going to investigate that. And then finally, I have a jar here from a pond a little bit closer to my home, but it's a pond that recently suffered a total ecological collapse, probably due to some treatment that the city gave the water. Because at one point, this ecosystem went from a really vibrant and diverse ecosystem to a graveyard of empty shells and basically a monoculture of ostracods, which are good survivors, but not indicators of a super healthy environment. So we're going to re-inspect, we're going to revisit this. It's been about 3 weeks since they treated the water. So we'll get a look and see how life has recovered. I think it's starting to bounce back because I can just, with the naked eye and that sample, I can spot more cyclops, or known as copepod. More cyclops than I had in the past. Alright, so where do you think we should begin? I think we should start with a clear water sample from each. That might be a good way to start. That way we don't end up with too much debris messing up our view. We can kind of just get a good baseline. I think that'll be good. I love this sound. Good morning, Tom. Good morning. Let me raise my cup to you. Big cup. So last night, I didn't do a stream as I was scheduled to do because me and my girls, we took a little road trip up out of the city into a dark sky to a place where we could watch, or try to watch, Comet Neowise. Drove way out into the country, ate dinner at a truck stop Wendy's, and then we found our dark spot. Pulled off to the side of the road. I set up my telescope. We did, made sure we were all looking at the right part of the sky. Spent the next 20 minutes just searching and searching and searching and searching. And we couldn't find it. Couldn't find it anywhere. It was getting disheartening. And then, via the binoculars, I spotted the slightest of blue smudges. It was unfortunate because the moon was so bright and so high that it definitely made it difficult. Made it a challenge. But I think that what I saw was actually Comet Neowise. So here's a trick that Pacific Plankton taught me here. Use this flashlight. I'm going to hold it up against the side of this glass. Here. I'll just do this work a little bit more where you can see it over here. I'm going to hold the flashlight up against the side of the glass. And that draws all of the little animals. I wish you could see it, but they're so small. They're smaller than fleas, you know, tiny specks less than 1/2 of a millimeter long. And they all just start to swarm across the jar and collect over at the end where I'm pointing the flashlight. It's a really neat visual effect. But then that gives me the ability to snipe one of these guys. I want this little one though. I get you? Am I that freaking good? Oh my god, I am that freaking good. I got the tiniest little... Got you. So I've got a Cyclops in this tiny... I don't even think you can see how tiny this volume of water is. But you know what? It's not tiny enough. That's still too much water to go on a slide. So I have to do some work. Sound! Dude, that is a lovely, energetic good morning, sir. Good morning to you, Sound. How are you doing? I am tracking right now a tiny insect in this volume of water. Probably the insect could not be larger than 1/3 of a millimeter. It is a speck. But if I can get it down into the lower portion of this water, and I'm just going to try to get it in a single drop. Stubborn. I got it. Your boy has the steadiest of hands. Because I just corralled. We'll measure it. We'll measure it. I got it on there. This is another baby Cyclops that I just managed to corral a single individual here. That's so small, I can't even tell if it is a Cyclops. I think it might be, but it's really moving around a lot. So we have a challenge now, because if I just drop the slide on it, I run a really great risk of killing the insect. Or the animal. It's not an insect, it's an animal. I don't want to kill the animal. At least not right away. I want a live sample to view. So we're going to pull out another trick that Pacific Plankton taught me. But first, let me catch up with chat. You're almost closing in your Sunday. Good deal. You got a bunch of sales closed today, but you're not even a salesperson. Did you get made to do work that you don't normally do? I know how that goes. So just as I'm finishing up making this slide, look at this Daphne. Look at her heart's beating. Isn't that neat? So what I'm going to do is I'm going to take this little cover slip. I don't even know if you can see it there. I'm going to break it in half. And then with half of a cover slip on each end, I should then... Oh man, it shattered. This should allow me to make a riser. And I'm sure that this little creature is not so big that he's going to get crushed by one riser. So hopefully... Gotcha. See it. I got an air bubble in there too. How unprofessional of me. Alright, let's see if we can find this bad boy. Huh? That's not it. Wouldn't that be amazing? Lined it up. I think this is it. Let's get a focus on an object here. Hang on, let's see if we can find it. That ain't it. I might have to use my eyepiece actually. So my camera attachment is a little too powerful to really get a decent overview of the entire field. So let me just take the eyepiece for a second and just let's identify where we're at here. Oh man. Could have sworn. Ah, there you are. I think. Oh, bingo. It's a Daphnia, I think. Yeah. All right, let's get a closer look now. I think it's bright. Your internet lagged so bad. Oh no. There he is. Possibly she. Daphnia. Or pretty sure that's a Daphnia. Let's put it in dark field and find out for sure. Struggling to swim in this tiny little area. Yeah, that's a Daphnia. It is a juvenile. This is a very, very small Daphnia compared to, this is the smallest one that I could see actually. So that was kind of neat. That's not my flashlight. Neat. So you can see, pretty sure this is all the stuff that she's digested. This like kind of pale line through her body. Usually if you spot an organ that seems to snake through the organism's entire body, you can usually call that the digestive tract. So interesting how it's got this like, you can see why they call these water fleas. They've got that foot that just looks like it's meant for hopping. You know? Okay, so that wasn't even the real sample that I wanted to take from that jar. I just got distracted by wrangling a copepod. I mean a Daphnia. So now we're gonna do what I initially said I would do. And that is pull a sample. A somewhat clear water sample. I get so many weird looks when I go to the pond to collect muck. People think that I'm out there to like catch fish from the pond or something, but then I'm just scooping a big wad of algae out. I wonder what this behavior is. It seems to be, is this eating or is it just struggling to get around? Interesting. What is this? There's stuff going in. Hey, wee! Going crazy. Well, it's in between two pieces of glass right now, so it's probably not too happy. Now, speaking of that, let's make sure there's nothing in here I'm going to squish. The playing piano. Yeah, twinkle toes. Alright, nothing visible to the naked eye in this sample. So let's get ready to pull that one up. I'll set aside this Daphnia for now. She'll live on the slide for a little while. Oh man. This is disappointing. I did this slide wrong, so it's only half set. It's going to cause there to be some flow issues, but that's okay. We will overcome. A diatom right off the bat. So we're looking at a mucky sample. That's a diatom right there. I don't know, there's always these little guys cruising around, and I'm not sure what they are. They're just way too small for me to easily identify. You know?
Pick up your phone and no one is there. And for a while I was really scared of them. Like, it's definitely something that
Thought I saw this moving.
every day, but once I knew
Diatom there, I
what was
imagine.
going on
And another one.
it made a lot more sense and I became okay with it.
Thank you, Sound. My family is okay. My immediate family is alright. My uncle is not well. But it's a situation that I don't have any power over. And it's a situation that I'm actually very familiar with. Hello. Well, about 3 years ago, he rode his motorcycle drunk. And rode his motorcycle drunk off the road. And seriously injured himself doing that. Now, I'm told he was actually wearing a helmet at the time of the crash. But I'll be perfectly frank. He always told me that he didn't like wearing real helmets because he didn't believe in them. He believed that if he was going to get into a motorcycle accident, he wanted it to kill him. He told me, I'd rather just go out doing what I love than linger. But that isn't what happened. He survived his wreck, and he's a quadriplegic, which, given a lot of other issues in his life and personal life, which I won't get into, definitely makes things very, very challenging. Well, what happened is his caregiver, apparently, had been mistreating him, and so he got rid of her, but that leaves him in a sticky situation where he can't get anybody to care for him. And because of coronavirus, no care facilities are admitting any new patients. And because of coronavirus, you can't just get 24/7 round-the-clock care at the drop of the hat, which he needs. So it's not a good situation. Anyways, I'm not here to use you guys as therapy. But I'm perfectly comfortable talking about myself and my personal things. Like, it doesn't make me uncomfortable, so don't feel weird about that. Like, I'll always tell my stories. I'm always happy to talk. But I also know that sometimes we don't come onto Twitch so we can hear somebody else's sad story, right? I got a funny story to share with you guys. Good morning, everybody. Out 3, rainy drainy. Hi, guys. Thanks for coming through. Hello, beautiful people. I just had to open up a new box of cover slips here because I'm starting to run out. So we're going to make another slide here. But first, we're going to look around. There's some interesting stuff here. This green piece of algae here keeps sliding around. Some algae is able to move, which I think is interesting. Sando. Hey, Brando Sando. I remember you. I always just call you Brando Sando. Alright, so let's see what else we can find in here. Anyways, my point is that the thing with my uncle is not great, but there's nothing I can do. It's one of those situations where I have no power to improve the outcome in any way, shape, or form. So I'll just, I gotta provide support in any way that I can. Thank you, Zounds. It's just kind of cruel and tragic where it looks like what will have to happen, and it's not good. But I don't want to talk about that too much. Unless, of course, it's what we're into. Alright, we're gonna go to Darkfield and see. Let's get some extra light on this subject. Some kind of algae. What is that moving? I'm trying to figure that out. It's definitely some kind of algae. So we know that it is an autotroph, meaning it makes its own food because of that green color. The green color tells us that it is a piece of algae. Some algae moves. It's able to move on its own. The stuff, this white scummy stuff around it is actually, it's dirt. This is probably silica, or I wouldn't be able to give you a chemical analysis of it, but knowing it's the brown pond muck at the bottom of this jar here. But when you get just a few grains of it, turns out, looks white. But also what we're looking at is, this is called dark field, so there's a light on top of the microscope that's shining light down from above. So rather than looking at transparency and looking at what light comes through the subject and getting an internal structure, we're looking at what light gets reflected off the surface of the subject. So the dark field gives us a look at surface, color, texture, sometimes in a greater detail than we can get if we just use the regular backlight. So that's where we're back on here. Yeah, I'm not sure what that is. We'll have to identify that algae. There are so many different kinds of algae, and they all behave in different ways. I don't think it's a diatom, though it does seem to have a similar shape of this object. Hard to say. Come on, let's get one more peek at this algae, and then we'll move on and find something else. So, back in this jar, this is the wasteland jar, we'll call it. This came from a pond that basically got collapsed by some city water treatment thing, and boy, it stinks. There's a piece of a diatom, I think. Seems to have that shine to it. Once I find a primo example of a diatom, I'll stop and give you guys a rundown of what they are exactly. So I went and saw Comet Neowise this weekend, or last night. That's why I didn't stream like I normally do on a Saturday night. It was very difficult to see. And to be perfectly frank, it was pretty underwhelming. Very faint. But it was still neat to go see it. Now I can say that I saw Comet Neowise when I had the chance. Let's see. A whole lot of muck. Bigger grains. Lots of diatom shells. There's that guy again. So when you go down to the bottom of the jar, collecting the muck and the filth at the bottom, what you're going to get is a lot of bodies and corpses. Now this is a great view. Let's get closer on this one. So we were at 100 times magnification. We're stepping it up to 250 times magnification. Very pretty piece of algae here. Let's get a measurement. Thinks we're at the right spot. That's not right. It thinks we're at the wrong one. We gotta be at. My calibration is all screwed up, so I have to tell it we're at 937 times magnification in order to get a decent shot here. Tenth of a millimeter. It seems more likely. Anyway, so algae like this, you might wonder, why would it need to move around? Doesn't need to hunt prey. Won't notice if it gets eaten. What's the purpose? Why does it need to go anywhere? It's mostly so that it can travel to brighter areas. It follows the light. It really is pretty with these two chambers. I don't believe this is a diatom though. No, this is just a regular algae. Diatoms have really pretty opalescent glass bodies, actually glass bodies. And they're very obvious when you're looking at them. See, not enough light on the subject here. If that was a diatom, it would have a very distinct rainbow shine on it that I'm not seeing. This, that is a diatom shell. Come back. Oh no. Fuck! Bumped it. That's annoying. Also, this music isn't what I want. Annoying. I had a really pretty guy here, guys. And I lost it. Anyway, what video game am I gonna play later? Oh my god, the worst thing happened in Minecraft. Oh no, my daughter and I have a Minecraft world that we share together. We've been it's survival. Because she's, as a 9-year-old, sometimes it's like they want to just play creative. And I'm like, no, creative isn't going to teach you anything. Like, in creative mode, there's no challenge, there's no growth. You literally just, anything you want, you have instantly. I'm like, no, that's not what makes Minecraft a valuable game. Instant gratification isn't it. What makes Minecraft a valuable game is that it teaches kids and adults very valuable soft skills. Soft skills like planning, perseverance, grit. It teaches kids grit. You have to face monsters. You have to defeat them. The monsters will sometimes win, and you have to rebuild. And sometimes, even if you do everything right, the monsters will still win, and you'll still get your house blown up, and you'll still have to rebuild from a crushing loss like that, and it'll suck. But that is okay. More algae. Dark field isn't giving us much on that sample. This crescent here, with the little spot in the middle, kind of looks like an eyeball. That might be a diatom. Hard to tell with one so small, but... Alright, so... I don't know what I got in this sample here, but I'm gonna let some of the grit settle a little bit. heavier grit, I want to lose it. There we go. So if I let things settle down to the bottom of this pipette for a little bit, we're going to get a denser sample of the loose silt at the bottom of the thing. Sometimes can contain wonders. Sometimes. Sometimes it's just boring. Would you guys be down if I went and played some Minecraft later? I'm just not sure though. It's just like my feelings are hurt about it. Because I went down to the nether and I lost 32 levels of experience. Because I didn't know that when you fight a ghast that all the pigmen would go nuts on you. So all the pigmen went nuts on me. And I did not survive. I did not survive. Let's step it back a little bit here. A little too close. Alright, that's probably it. Still gotta get those petri dishes so I can start farming and hunting water bears. That's really what I want. I want to hunt them water bears. Not so sure about Minecraft. Well, the Minecraft's coming later. I've got a bunch of samples to go through. We'll be doing this for a while yet. I'm not rushing to go play Minecraft. I just know that at a certain point, I'll have tired myself out looking at water samples. It takes a while though for me to get tired of things. That'll help being at the right zoom level. There are Daphnia parts. These are probably molts. You can see there. That's a Daphnia head. And that's its carapace there. And you can see the scavengers inside. So maybe this is a dead Daphnia and not a Daphnia molt. They can look the same, right? Because when a Daphnia dies, its body... Daphnia are interesting. They're actually denser than water. Unlike a lot of water animals, which are buoyant neutral. So they can just sort of use the least amount of energy to get around. Daphnia are heavier than water. So with no assistance, they sink to the bottom. That's why they have those big strong kickers. So they can always get back up. They swim very strongly, but without swimming, they sink. So what that means is when they die, their corpses sink to the bottom. The mud and muck at the bottom of ponds is almost entirely consisted of the corpses of the microbial life that lives in that pond. That's what dirt is. Little piece of plant matter there. I keep finding these little red fibers. And I wonder if they really are actually fibers from someone's clothing. 'Cause I know that some people bathe in this pond. You know, people that need to bathe in public ponds. There goes that little guy. I don't know what those are. Are those little baby, like baby Daphnia or ostracods or something? Or are they a different species of something? I don't know. Because you find them, you know, jigging around inside of other things. But yeah. So far, this is the collapsed pond. So far, I'm not seeing a lot of signs of life coming back, or at least not bouncing back strong. Same as last time, lots of body parts. It looks like a battlefield. You know, there's just disembodied Daphne and copepod parts everywhere. Alright, let's go to a different slide. We'll come back and try Collapse Pond another time. There are things living around just in the water here. I do see a cyclops. That was a big one. Lots of eggs on her too. Let me try to capture one. Do you guys want? I'll let you guys decide. I can try to corral a single sub-millimeter cyclops, which is actually really fun, but probably not the most exciting thing to watch. Or move on. We can try to image this mysterious goopy stuff. Because I got a mystery to solve over here. I don't know what it is growing on this. We got options. Where's that? There it is. Mysterious goopy stuff it is. I don't know what it is. So I'll try to describe it as best I can, because it is difficult to... I definitely can't show you on my cameras here. So, I don't even know if you can see, there's that ball floating right here. That's like a seed pod. And so there's algae tendrils hanging off of the seed pod because it's been floating in a pond long enough. And at the end of each tendril of algae is like a corona of semi-translucent white jelly. And it almost looks like a freshwater jelly. It's translucent. It seems to be coalescing in these like coronas around the tip of the algae stem. Almost like broccoli, like it's making like a reverse broccoli look with the stem and then kind of like this fluffy cloud around the end. My concern is that by taking a sample, as soon as I pull it out of the water, it's gonna just deflate, you know. But we must experiment if we're ever gonna find out, right? Here's my scissors. So what I'm gonna do is try to pull up one strand with the tweezers, snip it with the scissors, and then I'm just gonna lay it on a slide. Obviously, we can't do a cover slip for this because I'm going to have that would flatten the specimen. So I'm going to just try to do it sans cover slip. I'm trying to see if we got any on this one. Oh, wow, there's a flatworm swimming in there. Oh my god. Diversion. No, I want to get that goopy stuff. Flatworm's not going anywhere. Oh no. It got stuck to the inside of the pipette. Okay, there we go. I got it free. Alright, so we're going to be looking through a somewhat thick water sample here. I'm not going to put a cover slide on. We're just going to look at it through the surface. And I did manage to get our mucky translucent stuff. And boy, is it alive. Hello. Is that a swan tear? think this is a swan tear. Wow, I did not expect this thing to be moving so much. There's another one, and another one, and another one. Guys. Wow. I wonder if that goopy, slimy looking stuff is a reproductive thing. Oh, and look at all these stentor and rotifer. Holy shit, guys. This is a crazy sample. We found a blue one. We found a blue. It's eating cyanobacteria. A blue ciliate. Oh my god, come back. This is so exciting. This guy. You see all this color inside? It's from the breakdown of the cyanobacteria. Look at him go. You can see its ciliates just furiously beating at the water to create the vortices. And this is the goop. See these strands? What are all these? These are all vorticella. The strands and the goop and the clouds are all vorticella, but they're so thick. That's amazing. Wow. So, hang on. That's so neat. I've just got to draw it so I can kind of picture what we're looking at here, and I can describe. So freaking neat. So, I don't know if you can make it out, my little dinky drawing here. So we have, you can't really see it, sphere, and then each of these hairs coming off of it. We're looking at the end of one of the hairs, and at the end of that hair, it is covered with a branching corona of further hairs, and at the end of each one of those hairs is an organism called a vorticella. And a vorticella feeds by waving its ciliated mouth, like so, and creating a vortex that draws food in. But look at the sheer force when all these vorticella team up like this. Look at the maelstrom that is the water just beyond the vorticella's reach. You see this? That's how they remain so full, and they eat so much. They just sit there and just suck food in. I was anticipating that white cloud would be something alive, but I was not anticipating that it would be 100,000 somethings alive. So how many organisms are in this shot alone? Rotifer, stentor. This is a big stentor. This is not a vorticella like the other ones. Another stentor here, swimming in a sea of vorticella. Let's go to dark field. This is going to be interesting. I've never seen a stentor that big either. This is really something. Oh, it hid when the light hit it. Remarkable. This white blob in the background here was it. Wait for it to come back out. It's gonna re-extend. Come on. Come on out. There you go. I see you, baby. Come on. Oh, come this way. Come on, baby. Really neat. Wow. Now, stentor can actually detach themselves and go find somewhere else to sit, which that's what it looks like it's doing. It is no longer attached, unless it's got a little body shell that we can't see. Sometimes stentor will form a gelatinous shell that sort of anchors it to its place. But no, this guy's on the move, it looks like. But yeah, they can find anywhere else to sit. Stentor are pretty neat. They'll just get up and move around. Unbelievable. I'm not done looking through here. There's gonna be more. Oh, see, there's that Stentor on the move. Oh, come back here. Wrong way. Where'd he go? Lost him. But he'll swim around until he finds a more suitable spot. There goes that big rotifer again. I've never seen so many. I mean, look at this loose Vorticella. Vorticella can do this too sometimes, but sometimes Vorticella will be able to intentionally, you know, unhook themselves from a surface, and other times they'll actually just get broken, and you'll see a little Vorticella out there just spinning in circles because it's got no counterweight, and it'll just spin itself into circles. It's pretty funny. So many Rotifera, so many swan tears. We're gonna look at another one of these for sure. I didn't anticipate such diversity. I thought it was gonna be a moss, not a full forest of these things. Look at the mouth on this Rotifer. This Rotifer's over here pretending to be a Vorticella. Day 3. Nobody has figured out that I'm not a Vorticella. I see you. I know you're not a Vorticella. Can't fool me. He's just along for the ride, this guy. Come on. Around and around and around he goes. See what I mean by maelstrom? You can really see this full circle right here. It's being caused by the collective action of all of these little tiny hairs. I love Rotifer. These Rotifer are so interesting because they open up their... It almost looks like they have 2 mouths. Rotifer comes from the Latin wheelbearer. You can probably see why they got that name, wheelbearer. Looks like they're using wheels to spin the water around their mouths, especially in that view. With the head on, and you can see, doesn't that look just like a spinning wheel on his head? Really neat. This is such an unexpected find. I can't wait to share this clip with my science buddies. Oh, wait a minute. I'm gonna move this a little bit here. There we go. Makes it easier for me to shift the slide around. There's that Stentor again. Trying to find a new home. Get out. Other way. What's on the slide? A really surprisingly diverse sample here. So far in this slide, we've seen swan tear, Rotifer, Vorticella, Stentor. I think I saw Euglania or Eugenia. I forget the name of that other little organism, but it's a huge diversity on here. What I did is I went to a local freshwater sample and I pulled a pretty clear sample, but what I noticed was at the end of these algae strands was this weird kind of white cloudy corona. Looked almost like broccoli. What it turns out these are these incredibly massive Vorticella colonies. I mean, look at them. And then there goes another swan tear. These massive Vorticella colonies. And then inside of these massive Vorticella colonies, you've got rotifer trying to just blend in. And the rotifer just kind of get in there and be like, I'm a Vorticella. There goes one. Now that, something else. That's one of these Euglenia, I think. Hard to say. There's another. Is that the stentor? It's hard to say because I didn't put a cover slip on this sample. Oh no, that's our ciliate that's been eating cyanobacteria. So it's got this blue-green color in it. That's a big fat ciliate too, guys. Let's look here. Let's put it on dark slide. How you doing, Dieter? How's the day? Can't get you in focus, can I? Not behind that. That's too bad. He's a chunky boy, Sando. Well, let's get closer. The only thing that could intrigue me more than this view right now is a close-up of this view. So, let's leave behind 100 times magnification and step up to 250x. How's that? You're good? I'm glad to hear it. Yeah, it's a nice, relaxing Sunday today. Last night, I took my wife and daughter out to go see Comet Neowise, and it was underwhelming. I had to travel to get a dark sky, and then it just wasn't very bright. But we saw it. We can say that we saw it. Interesting. The fusion, the line between the stem of the organism and the organism itself is so firm. You can see it almost has a completely different color to it, right? And now these Vorticella, it's just so amazing, the diversity of different organisms. These Vorticella, when they retract, they don't snap their whole stem back, which is interesting. That's not what other Vorticella do. Watch this. See, these Vorticella, they retract their entire stem. So when they feel threatened, they snap all the way back down. You can see over and over and over again, they open their mouths, they start to feed, the vortex regenerates again, and then something frightens them and they snap back down. They might be frightening each other, but this is how I usually see Vorticella behave, is they retract on their entire stem. The entire stem snaps the organism back in. But there's a huge diversity of behaviors. These Vorticella, when they feel threatened, they seem to only retract their bodies like that. Now, maybe this isn't for threat. Sometimes this retraction is actually a swallowing action, and it helps get food farther down into their digestive tracts. Can't say. A little family of swan tears. I have such a hard time taking a good recording. That's its mouth, I think. I want to film one of these eating. I mean, everything's eating all the time in here, isn't it? Yes, it does. Sando. Oh, thank you so much for noticing that. It is such a pain in the ass. I have to convert all these WMVs to MP4s before I share them anywhere. It's obnoxious. But this is an old piece of software if you can't tell just by looking at it. Rotifer. Yeah, it makes all these old WMV files. It's pretty wild. Look at him go. Here comes another. Oh, I love how they inchworm across. Look at him grabbing it with his little toe. He's got his two-toed foot, and he's holding on to the string of the Vorticella. I love watching these things move around. It just mystifies me, you know? Oh no, wait a minute. Oh, that's just a Vorticella snapped off. Thought it was something else. What are you? What is what is that? What is that? It's raw, you fucking donkey. This might be. No, it's so lumpy shaped. That can't be a radiolarian. It's so lumpy. But look, it's got food stuff stuck in its spines. This is usually how radiolarians and heliozoans will collect their food, is on these spines, and they just kind of skewer stuff, and then over time they're able to eat off of their spines. But it's so lumpy shaped, guys. I don't know what that is. Mold, what's up, dude? And Gamecation. Yeah, it's The Cube. Oh my god, that movie. The Cube. I don't know what this is. Again, radiolarians are very spherical. So are heliozoans. All of the spined creatures like this that I know of are not. Did that Rotifer just go try to take a chunk out of it? What the? Is it eating that? Nope, it's moving on. Oh, I love these guys. Look at him with his little helicopter. I love how these guys use their cilia, or their flagella. They hold it out in front of them, and then they like kink the end at 90 degrees, and they spin that like a little rotor. So it's like a propeller in front of the organism. It did look like he took a chunk of it. Like he reared back, he was like, hump. So this creature doesn't seem to be able to move itself. It's just adrift on the currents. Like these detached Vorticella. They're just stuck. But I still don't know what it is. Look at the work that the Vorticella does. Look at the current. I use the word maelstrom a lot. Because when all of these little organisms get together, they all work together. Holy shit, Sando! My goodness. You know, thank you so much, dude. Holy cow. Wow. Thank you for the sub. I really appreciate it. So much. It's really cool of you, dude. Again, subbing, donations, all of this is not necessary. I come here to do this for free. I'm happy to do it for free. When money happens, that's really cool, but I wish I knew what this was. I wish your sub could just identify that. It's just what is interesting to me about it is it's really disorganized spines. And they're only on one half of the organism, right? Isn't this side, I'm using my hands to gesture, isn't this, you know, from noon to 6, it's fewer spines. It's very bristly over here, though. And it's just stuck in this Vorticella colony. So is this guy. Look at him move. He's just spinning like a top. Alright, Let's see what else we can see. I'm done hemming and hawing over that mystery. I got a few pictures of it. Oh, did I get an image, video of it though? I want to make sure that I got what I need. Photo. That's not quite the best picture of it, is it? Well, now I'm not going to get one. Some mysteries may never be solved. It's funny how you can just get a little bit closer and suddenly a whole new layer of discovery. There's one. I love these little ciliates. These guys are so charismatic. They really do walk around on these little, on their little feetsies. Hello. Slug? No. Where'd he go? It's like every single thing in here is life. I think that this is called a swan tear mold. It does get around though. Makes it hard to focus. Look at this rotifer. Stretchy boy. Yuck. Yeah, they are. All of these seem to be very much, all of that particular organism, they do have a very uniform shape. Unlike the rotifer, which don't seem to care if they're actually rotifer, like the diversity of the different, just the forms that I keep seeing these rotifer show up in, it is remarkable. They don't seem to care what they're supposed to look like. Got a foot? Got a mouth? You're a rotifer. Alright, dude, get some sleep, Zound. Thanks for coming through, man. I appreciate it. See, look, here's a rotifer pretending to be a vorticella. He's perfectly content living as a vorticella. So some rotifer are always swimming around. They're always moving, looking for food. They graze like cattle, just eating as they go. But this rotifer has anchored himself in this colony of vorticella, and he's like, I'm just gonna be a vorticella. Like, that's cool with me. I think that's kind of funny. Meanwhile, this rotifer is just, he's having such a bad time. Oh my god. He can't get out of this vortex. Maybe that's why he's so stretched out. He's just desperately trying to grab onto something. He wants to get off Mr. Bones' wild ride. There's another rotifer pretending to be... Oh, hello. I'm tired of Mr. Bones' wild ride. Mr. Bones' wild ride never stops. Yeah, it's a vortex. Ah, that's blurry. My god. Get in there. This is craziness. There's so much happening in this slide, guys. It's hilarious. There's that Stentor again. He's like, can I? He's just trying to find a place to park, man. There you go. Again, stuck in the vortex. See, he's got food stored. I know that's a heterotroph of some kind, because he's got food stuck in his spine like that. That is usually a sign. What are you doing here? I wonder if these guys ever stick their long noses into vorticella and just take food right out of them. Yeah, Mold, the vortices, the vortexes rather, that these organisms are able to create are amazingly powerful. It's all a matter of scale, right? On this scale, it takes so little pressure and force to move the water. is a ciliate. Huh. Tiny little guy. I mean, we're talking itty bitty. 950 microns? Or is that 95 microns? I forget how that measurement goes. 0.095 millimeters is, I think it's 950 microns. Let me look it up or double check, because I want to sound like I know what I'm talking about at least some of the time. You know? Let me just look it up. 0.095 in micron. 95 microns. Microns. Okay, yeah, 95 microns. Not 950. Orders of magnitude are important to get correct. 95 microns. All measurements are estimates. I am not the most 100% on how well I calibrated this thing, but wow. They just go around and pick up little bits. Little bits. Come on down to little bits. You're a rotifer, aren't you? Why are you acting like that? Hang on now. This is the second rotifer I've seen that seems to have a little something on its face. There's that ciliate again. I don't know. I think these guys are really cute. See this thing here? That. What is that? The other rotifer had that too. I don't know what that is. I don't like that. It's got like a thing on its face. How'd you get that thing on your face, dude? Sir. Oh, watch out. Yeah, I don't know. It's on the other side of it now. Where'd he go, buddy? Come back. Man, it's amazing how fast they can just move. They'll just disappear. Could be a tracking beacon. Beacon on. Hailing all frequencies. There's our mysterious object again. Oh, Rakasepta. Thanks for the host, man. That's cool. I love that. I try to keep my host list updated, so that's cool. It did look a little more spherical. Hard to say. Look at, you can see the cilia covering this entire organism. See the kind of staticky, hazy shapes around it? It's covered in hairs. They're all doing this. They're all moving around like that. But these hairs are usually so fine, it can be hard to capture them, but that's cool. Now, each of these little globules you see there, these are food vacuoles, I think. The way that these things eat is pretty neat. I wish I could see you eat something. Eat something. Come on. I'm fairly certain these are the ones called swan tears. As was so pointed out by a Twitter user. I got a funny story to tell you guys. I was reading a little Reddit thread about just funny events in history. And I found a fun story about the origins of the Mile High Club. So it's thought that it's possible that the Mile High Club was the reason that the autopilot was invented. Let me find this story here. Yes, pilot engineer Lawrence Sperry. Yeah, let me find their story. It's pretty funny. So, website using the name Mile High Club attributes Lawrence Sperry as the club's founder. So, it was the year 1914, and Lawrence Sperry was teaching a wealthy socialite, Mrs. Waldo Pierce, how to fly over New York. At the time, Miss Waldo Pierce's husband was in France driving ambulances, being a hero. Miss Waldo Pierce is getting flying lessons from Lawrence Sperry. Well, apparently one day, as the couple were flying over the bay, they were experimenting with Lawrence Sperry's new autopilot feature, which we can only assume he devised this autopilot so that he could enjoy a tryst aloft with his student protege and socialite lover. So as Miss Waldo and Mr. Pierce are engaging in illicit high-altitude coitus, something went wrong with Sperry's new devised autopilot, and the plane plummeted 600 feet into the bay below. Miraculously, both Sperry and Waldo survived. Apparently what happened is a pair of duck hunters out on the water saw the plane go down, and they all paddled out to the wreck and discovered, to their amazement, a naked couple in the wreck. Lawrence Sperry apparently told the fishermen, or the duck hunters, that the crash had divested them of their clothing. Apparently, Sperry walked to the hospital with Waldo alongside in a stretcher. It's not known if this incident caused the end of Miss Waldo's marriage, but what is known is thus began the legend of the Mile High Club. I just love that it ended in a plane wreck, and it was possibly the reason why autopilot was invented. This guy was flying this smoking hot socialite around for so many days trying to teach her how to fly, and he's just getting hornier and hornier. And then finally he's like, I gotta do something. If only there was a way this plane could fly itself. If only there was a way I could get this motherfucking plane to fly itself, then I could finally get some. So he did. He made an autopilot. And when it failed, he almost killed himself and his lover. But thus began the Mile High Club and autopilot. I don't know why this silhouette, I think it's such a cool design. I don't know why I think it's like, I don't know, look at that. I just love it. It's just sitting there, happily eating. Please don't move. I want to see you in Darkfield. The power of boners, inventing new things. That's right. I feel like so many of innovations in history were made by desperately horny men trying to impress a woman. This interesting looking rod shape here, just coming in off the right side of the frame. God, these rotifers dive bomb. What is up with that? Anyway, this rod here, this diamond-shaped object here, these are all diatoms, which are among my favorite organisms on Earth. There goes that centaur again. These diatoms are remarkable creatures. Wow. In Elite, when your hard points are empty. It's interesting how these rotifer are behaving. They're like, they seem to swim in and dive into the... Wow. So this rotifer has a really interesting move. Where yeah, it does have that thing. Again, I just saw it. It's now hanging off the backside. Look at its gullet working. Gulp, 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 gulp. There's a diatom. It's a beautiful image of one. So this algae lives in a glass house of its own creation. It makes a silica glass house that literally lives forever. When these organisms die in mass numbers, and they die in the ocean, and they actually sequester carbon and carry that atmospheric carbon down to the seafloor, where it stays locked away for billions of years. The Earth's beaches are made of destroyed, crushed up diatoms, as well as actual mineral content. These little organisms are one of the most important bedrock organisms on planet Earth. They are said to create, I think, 35% of Earth's oxygen. They always say that the Amazon is the lungs of the Earth. But really, the Amazon does part of the work. The rest of the job is done by the oceans and the water channels that are all bearing billions, the gigatons of biomass in diatoms. They serve a very, very important role in the ecosystem, not just in the production of oxygen, the sequestration of atmospheric carbon, but they're a foundational, they're a bedrock feed species for so many other organisms. They're very sensitive to their environments as well, so you can often judge the health of an ecosystem based on the number and appearance of its diatoms. This is a pretty healthy ecosystem, despite it being a relatively clear sample, and I'm very impressed with the health of this pond. Compared to some of the other city ponds, i.e. wasteland battleground pond, I don't know what happened there, but they killed everything in that pond. The city did at some point. There's another diatom right there. Don't get eaten, buddy. Lex! Hello, Lexington, my friend. How you doing? We found a craziest sample, dude. Now that is not a swan tear, I think. No, it is. It's just not flexed out that way. Hunting. Yeah, I'm okay too. I got plenty of things I could complain about. Really is a micro party. This is one of the densest, most vivacious slides I've ever dropped. There's that cilia again. I love those little guys. I don't know what these guys remind me of something cute. Can't put my finger on it. But I got a cute video of one of these guys literally just like walking around on his cilia. It's really cute. There's so much life. Here, let me just take it back a step again, Lex, so you can get a bigger, broader picture of it all. It's truly teeming with life. Rotifer, swan tear, ciliates, vorticella, diatoms, euglenia, all in a single frame, and probably more that I can't identify. Yeah, rotifer going. I think it's time to try to grab another sample. There goes it. Oh man, that's one of those long rotifers. I didn't know these guys could just swim so effectively. Like, he really just gets around. Look at it, he's gonna turn himself. What are you doing? He also has this little extra dangly bit off of his face. Sometimes when he turns, you can see it there. Uh-oh. Here comes another one. Wow. This is so... I think it's really neat to see these two organisms interacting like this. See, all of these rotifer have this extra dangly bit. There's another piece of anatomy on these rotifer that I've not seen, and their behavior is different too. The way that they are fully extending and moving around in open space. Like many of the rotifer that we've observed in the past seem to stick to the sort of the mucky area where they can grab onto stuff. But these guys are so comfortable just walking around on the glass. They have no issue just hanging out wherever they are. He do extend. Let's get a measurement on the full extent. Oh, not. I didn't mean to F9. Shit. I wanted to F8 this. Stretch it out. Give me a stretch, and I want a straight stretch. Bingo. So we're looking at, yeah, I think we got our measurement right here too. Wow. 0.2 of a millimeter. This is a somewhat accurate measurement. It's not going to be the most accurate, but I think it adds up. Amazing. Find out what he's compensating for. Why he's got to keep extending like that? Lewd. Senpai, why are you extending? He's trying to find a place to put his foot right now. He's like, where can I sit? Earlier, Lex, we found some rotifer that were just hiding among... There's one. This rotifer is like, it's day 4, and nobody knows I'm not a Vorticella. It's so funny to me. I don't know why that just tickles me. There's all these Vorticella, and then this rotifer is like, just don't mind me. I'm in here. Wow. So, I'm tempted to look in this sample again and try to grab another one of those little mucky clouds. What do you guys think? Should I try to grab another Vorticella colony? Because I've got a few more floating in here that I could scoop up. Gosh, they're beautiful, though. They're so delicate. Alright, gamification, get some food. A man's gotta eat. Oh no, poor Vorticella lost its home. This is just wild, how busy it is in there, you know? Alright, let's try to grab another sample of something. The way that I'm going to do this is I'm actually going to cut free a tendril inside the water. That way. Because they really do collapse as soon as you take them out of the water. It's like the blobfish, right? As soon as you take it out of the water, the whole thing just folds. So I have to there we go. I'm just trying to sever the algae with my scissors a little bit, cause it to float away some. Then I can draw on it with the pipette a little easier. is. Hang on. Just a little bit more to snip in here, guys. It's a challenge, though. Hang on, what's going on here? I wish I had longer scissors or longer tweezers. I need some better tools for this job, guys. I am not equipped properly. I make do with what I have, though. I do okay. Definitely don't have the full range of equipment that somebody would need to really do a good job here, but man, we make it work, don't we? Where's my flashlight? There it is. Wow. I think that's an ostracod. Oh, shit. Guys, there's a big flatworm down there. Oh my god. This is so much bigger than I could get on a scope, but I want to try. This is going to be hilarious because it's so small, but also so big, I don't think I can even. Oh, I got it. No, I didn't. Now I got it. I got a worm. Alright, guys, I got the worm down at the bottom of the pipette here. I'm going to try to get him onto the slide. Got him. Got him. I got the worm. Alright, this is going to be really hard because he's going to be moving around constantly. Oh. Just a moment, guys. Thank you. Just a brief overmute for a second. I was just saying, I don't know which, you know, I'm guessing one of these is its intestines, and the other would be its like heart or something. It's a cardiovascular system. Boy, you're gnarly looking. Real stretchy boy. A lot of these worms are so stretchy. Obviously. I wish there was a way I could get it to just hold the fuck still. I don't know which end is the front. I think this end is the front here. I don't see an eye spot on it though. Hi, who fucking tonight? What is this? This is some kind of worm. I actually don't know what kind it is. I just found it. Oh, there is an eye spot right there. Right. Right there. That's an eye spot right there, I think. Yeah, this is a really gnarly looking little worm here, isn't it? It's a stretchy boy for sure. Let's look at it in dark field. Oh yeah, old phone cords with the little curly Q in there. Wow. I'm sorry that I can't get farther out so we could see the whole organism. That bothers me. I wish we could. But my camera attachment is necessarily a little too close. Yeah, me too. I love things like that are just like, that's disgusting.
Little Hans says it's
Love
time
it.
to rock and roll.
Hey,
Bring the
Rockasepta! Thanks for the follow. I appreciate you. Look at this fucking gross, dude. I'm trying to get a pic, but like, it is hard to track this thing at the same time as using my mouse. I need like 3 more hands to do this, guys. Fuck. You know what's happening right now is the water temperature is getting hotter and hotter. This might be dying right now. Because this tiny droplet of water is being just blasted with a lot of light right now. Way more light than this organism is ever really used to receiving. He lives down in the muck, normally. And so, this tiny volume of water is getting hotter and hotter with each passing second. It's going to make it hard for this thing to live much longer. You know what? That's okay with me. One less of these in the world. Are you guys gonna be okay with that? One fewer one of these things. Bwah. Is that the stick man again? Look, guys, I had to illustrate that purpose to you. The malleability of the human brain. Poor Bob. Yeah, it's starting to writhe a bit more. Get a brief video of it. Look at this. What is happening in here? You see this? There seems to be some kind of valve. What is pumping inside of its body? I'm glad I caught a glimpse of that internal motion. You can see it again. Oh, I wonder if those are all hearts. A lot of these small organisms will just have like 30 hearts. These might be hearts. Each one of these might be a heart. They end up with really distributed organ systems like this. I don't know though. I'm gonna tweet this stuff out to my I've made a lot of science friends on Twitter. And so I'll ask a bunch of people who are way smarter than me what they know or what they can find out here. He's all heart. And look, behind each heart is like a little cluster of maybe eggs. See? Circle, circle, circle. Very interesting. Could also be a nervous system. But no, it looks like it's very... What is it doing? It's pulsating very intensely, huh? Alright. Let's go grab another sample. That was cool. I'm glad I spotted this worm. But let's say goodbye to the worm. Say goodbye to the worm, everybody. Say bye, wormy. And that segment right here in its tail, you see that? It's got a whole, it's like a little pinch there. Pinch. Yes, worm. Goodbye. Thank you. You were amusing. So sorry. Alright. Now, let me try to get us another one of these Vorticella colonies, because those are just way too cool to pass up. I really want to get another one. So, to do so, I'm going to need to cut some more algae off here. Can't tell if I got it. Nope, I didn't. It's a transparent thing. At least it's mostly transparent. It becomes really difficult to get it into a single droplet. Can't even see it in there. I think I got it. Can't tell. But you know what? I happen to have a tool here that specializes in looking at really small things. No, we said goodbye to the worm, Lex. That's all. We said goodbye, worm. Thank you for your service. And now I try to a somewhat clearer sample, but I was looking for our Vorticella colony in here. I don't think we got it though. It's fiber. Oh, there's one. I put a cover slip on this one. That flattened everything out. You can really get an idea of how fine-haired these are. Well, that's not nearly as interesting as the first one. Problem is, they're way down there. It's hard to reach these things sometimes. I want to just snip a little piece off of you. Yeah, gotcha. I see what I have to do here. Hang on a second, guys. A little patient with me here. I'm just going to try to coax this piece of algae up. This is going to be a good one. I can tell just by looking at it. Just got to get it up to the surface so I can pinch. Gotcha. Okay. This is going to be another one that we're going to do with no cover slip so that we can just get the full look. And here we are again. Back into a practically impenetrable forest of Vorticella. It's incredible, the density. Is that a rotifer? Yeah, there's our rotifer. It's real pretty green algae too they're all on. How neat is that? I really adore following up on my local waterways and just, every week check in on them, look at how the ecosystem is doing, see what changes in organisms you can spot. These are new. Last time I didn't think to collect a sample of these white clouds, but I'm really glad that I did. Here goes that swan tear again. Seems like these Vorticella are very friendly organisms. They form huge groups, and they let other organisms sort of very peacefully coexist with them. Namely, the swan tear. Aha. Wanted to look in true color. Sometimes you can see things that are more reflective than they are translucent. Very, very neat. Let's go back to the transparent view here. There goes you again. These guys are so cute. So I was thinking I'd do a bit of shopping for a 5 or 10 times magnified camera attachment for my microscope here. I think that's one of the biggest things that I could do to improve what we can look at, or to increase the kinds of things we can look at. Because right now we're stuck at a very tight magnification. This is as far out as I can get, which is not great. You know, we need to be able to do less than 100 times magnification sometimes. So there are larger organisms like that worm that I will never be able to fully image unless I get out farther. And I would love to be able to capture pictures of larger organisms. But right now I'm stuck. So that's something I got to look at, is a new camera attachment. Because I actually have 2 of these. This is an Amscope MD500 USB attachment for the microscope. It's the exact same zoom factor as this Dynocam attachment that I use. So it's kind of disappointing because I want to look at bigger things. I mean, I really do want to see bigger stuff, but it's hard to do. Okay, there's another one. I'm going to take a quick break here in a minute, but not yet. I love that story about the Mile High Club thing, though. That really tickles me pink to think that dudes, or this lady's cheating on her husband with her airplane instructor, and they crashed their plane because the autopilot didn't work properly. And he explains to the rescuers that the crash divested them of their clothing. I love that. The crash, that's why we're naked. So I really want to talk to somebody who has a lot of experience in this field, but what I want to do is create a sustainable biome at home. I want to be able to farm and grow generations of my own organisms like this. But I'm not sure how to go about doing that in the best way. I've got some aquarium bubblers so I can oxygenate an aquatic environment. I don't have a fish tank or something like that. So I was thinking maybe doing it in a 5-gallon bucket and setting up aeration in the bucket and then just sourcing it with local water. And then, you know, every couple weeks, could I go collect a few jars of pond water and like seed my home ecosystem with something like this? You know, get a bunch of organisms in there, oxygenate them, feed them with light. Would I be able to create an ecosystem? Because I'd love to be able to just go out in the backyard and grab a sample for the stream, instead of it having to be a big old trip to the parks and hopping fences and having to explain to strangers. What the fuck? Is that looking familiar, guys? What the fuck are you doing on a stem? That's strange, people. I find this strange. This looks very much like the guy that I thought I was trying to identify as a radiolarian or a heliozoan, but I wouldn't. I said no, but it's not round enough. It's not round enough, but it's got the spikes. Here it is. This appears to be living alongside all of these Vorticella, except it's not a Vorticella. It's on a stem. Mold, that'd be fun. Here, actually, I did one recently. Let me show you what I got. So I tried recently to make a sealed biome in this old wine jug. And I started with a gravel layer at the bottom, and then I took some fabric, some cloth, rather it's for containing soil, so I put a layer of that down, and then I put in some dirt and some topsoil in the hopes that it would create a liquid reservoir and make a closed water cycle inside of this jar. Now I succeeded in creating a closed water cycle. We get nice routine condensation and precipitation from the underside of this glass. As far as the ecosystem goes, though, it's just mold. I haven't planted anything. I tried transplanting some ground cover, little mossy things from my yard, but they all died. But I put in some bones, I put in some snail shells. So there's some stuff in there. There's some mold colonies happening underneath the ground, but not a lot. So I don't know. I kind of want to let this sit. Yeah, the 40-year-old bottle ecosystem. Exactly. Now, I was thinking about that yesterday because that guy did it with the intent to never break the seal, right? He made this sealed ecosystem that he would never open and only be able to view. And that was my hope with this, is I wanted something to just grow in here and I can just never open this cap and just enjoy a sealed ecosystem. But that won't do for what I want, right? Because I need to be able to extract samples from my ecosystem. That's what I really want it for, so that I can get my own. Grow my own little samples here. So that means that I need to look at something like a bucket. But mold, I've been looking for an excuse to do a fun, backyard stream for a while now. Because I have plenty of backyard activities. I do a bit of woodworking, I do my backyard archery, and any other kind of projects that come up. So I would be delighted to do a backyard stream showing how I put together or attempt to put together an ecosystem. Diatom's Attack! Oh, what's up? I know you. Thanks for coming through, man. Building a koi pond would be ideal, because then you get the entire ecosystem. My parents used to have one in their backyard, and I remember what a nightmare. It's definitely not within my means right now to build a koi pond. That's why I'm thinking about really cheap budget ways of doing this, like creating a small slice of an ecosystem in a 5-gallon bucket, going and collecting some local pond scum, Spirogyra algae, and just like seeding a mini home ecosystem with a few jars of pond water, and then I would only have 5 gallons of water to worry about treating and testing and keeping healthy. Yeah, cheap tanks. I've got a window in my garage, and I could build a little table for the window and set up a fish tank there. Because that'd be ideal. I'd love something with glass walls so I could see inside and be a little discerning about the samples that I take. Anyway, diatoms, let me catch you up here on what I've done, because this is a really amazing sample. I went to a local pond and I found a it didn't look too healthy, it was just a regular old pond, but it didn't have a lot going on in it. I noticed that at the end of every strand of algae that I could see, there was this strange white cloud. It looked like a broccoli, like a little white corona. And so I took a little snip of that, and I've never seen a denser colony of Vorticella in my life. it is just a thick canopy of Vorticella, and at a few points you can find a rotifer inside that's just pretending to be Vorticella. It's very funny. Blend in. Some of these rotifers are definitely traveling around and, browsing for food. They're very mobile. And then others are perfectly content to just anchor themselves and act like Vorticella. I live in a place, mold, fortunately, where I could probably just drive around and find one on the side of the road somewhere. Urban living, baby. Hello. Hey, diatoms. There you go. Nope, never mind. Those aren't, are they? Because I'm noticing now these structures here. Maybe those aren't diatoms. I know one way to check. I think my batteries are dying on this flashlight. Maybe not. Yeah, I love being a curb vulture. I'm not getting that all of those algae strands are diatoms. Okay, cool. All of these are diatoms then. Each one of those little things. Cool. Sometimes I'm not sure, but most of the time I lean diatom because there's just so many varieties of them. Sometimes they're mobile, sometimes they're not. I want to learn more about diatom reproduction because I understand that every time a diatom reproduces, it actually shrinks in size. And so there must be a certain point where the diatom reproduces in a more traditional way. Otherwise, they'd only ever get smaller. I've got more research, more learning to do. That's why I'm here. I love these little flagellates here because they use their flagella like an airplane propeller. He's all hidden in this muck here now. But when I was younger and learning about microbiology and learning about how different microbes move, I learned about the flagella, right? And I think it was depicted this way in cartoons, and it's a logical assumption to imagine the flagella being used like a fishtail behind the organism, whipping back and forth, undulating to cause the creature to move. But what I've seen is there's a lot of really creative ways that these organisms use their flagella. There's one that we'll probably see if we watch long enough that holds its flagella directly out in front of itself in a straight line, and then the last maybe 16th of its length, it crooks out at a 90-degree angle, and it seems to spin it around like an airplane propeller, pulling itself through the water. Really, really neat motion. Diatoms attack. They have cycles, mostly asexual. When they get to a size threshold, they switch to sexual reproduction and regenerate their size. That's what I think I had read that, but I didn't dig into it enough to get myself a full understanding of how that occurs. Right, because they have to hit a point eventually where they hit the reset button and have a normal sexual reproduction so they can create another large organism. Otherwise, we'd have lost the diatoms to the infinite smallness long ago. Now, I wish I had a better grasp on what all of these little tiny guys are. But that's a little different too. I have not seen one of these. What are you? I wonder if that's just another swan tear, but it's really funny shaped. It's a combination of small sizes and environmental cues. I'm really interested in how organisms are able to alter their sexuality and reproduction based on an environment. One of my favorite things to tell, what I told my daughter was that if Finding Nemo were a real story, Nemo's dad would have just possibly turned into Nemo's mom after Nemo's mom got eaten by that barracuda. That's what clownfish do. If there's a whole colony of male clownfish and there's no females, something happens. they can sense this, and a few of them will undergo a gender change. They'll become female clownfish. And so I've always been fascinated about how an organism's biology can so dramatically change, you know, based on these external stimulus. It's so remarkable. I love when the rotifer's cilia motion lines up perfectly with the frame rate of my microscope, so it just looks like it's stationary. I'm gonna have to take a trip and get some fresh water before too long. But I mean some salt water. I'd love to look at some saltwater diatoms. I am going camping in a week or so with my family. So my wife and daughter are going to go up to the mountains and do some camping. And better believe I'm going to collect some mountain freshwater. Here's the one I was looking at. Right now he's caught in a maelstrom, but you can, let's see if we can get a little closer. Come on, buddy. So I just paused it here. You can see there's his flagella extending off the back. Now, in normal conditions, this flagella is held straight as a rod out in front of the organism, and then it's got a little kink at the end, and it sort of spins it around like a propeller. But right now, he's proper fucked. That's gotta suck, man. It's gotta suck. Oh well. What are you gonna do? Get a load of this worm we saw earlier. Actually, let me show you the video of it because I saw an interesting thing happening inside of it. So these structures, I was guessing that this was its intestine. But then there's this attached structure to this intestine, to this organ. I don't know if it's intestine, I'll just call it this organ. This lighter, pinker structure. Watch it begin to pulsate rhythmically with an increasing intensity. Now, at first I thought these were hearts, but then I wasn't so sure. I think that the worm started to experience some distress, probably because the water was getting warmer. And I didn't put a cover slip on it, so it was probably evaporating pretty rapidly too. So I imagine that made it a bit uncomfortable, but I don't know what that is. I don't know what kind of worm it is either. That would help to know. So the rotifer that I see in this sample have a slightly different thing going on, and I'm trying to figure it out. Maybe I just haven't noticed this feature on other organisms that I've seen. Or maybe I know that rotifer have a very wide variety. So look, if we watch this guy long enough, it's got a raised node or something on the back of its head there. And it's mostly evident on these rotifer that seem to really stretch out. They get real long and they're very mobile. Like these rotifer don't even seem to walk on their foot like a lot of rotties do. They actually swim. There's one. Not caught. So look at his flagella. I always imagined that they would use the flagella behind him as a whip to move through the water, but no, in just a minute he'll straighten this thing out. I don't know what he's doing with it, waving it like that. That's not too common. Oh, and now he's gonna make a fool out of me. What's he doing? It's not caught in a vortex. I almost didn't see you. I think that's a helio or a radiolarian. You see this circle here? And all these spines. Sneaky, cheeky monkey hiding. Can't quite make it out. It's this lighter spot. I think. Can't see it this way, huh? It's almost invisible to dark field. But there it is. That's got to be a helio. Heliozoans, as I understand, what does it do? Helios are cool. They more or less sit there and they drift, and they're covered in all these spines, and they capture prey on their spines. And then some helios will extrude a stomach, kind of like an amoeba, where they'll go and envelop the thing they're going to eat. They'll pull it down the spine and digest it inside. But they're very casual hunters. They just sort of drift around and catch stuff on their sticky spikes. Sometimes their sticky spikes get them stuck in other stuff. But, hence all this muck here. You can't quite get a good look at it. But I'm pretty sure that that's a heliozoan and not a radiolarian. As I understand, radiolarians have a lot more evident complexity. So in a backlit situation like this, if this was a radiolarian, we would be able to see organelles inside. There would be multiple layers to this organism. But a helio is a little bit more basic. It just is a circle with spikes on it. The density of life in these drops of water is one of the things that is always keeping me coming back. What's going on? Why can't I get my measurement tool? Oh, it doesn't like to do it zoomed, I see. Oh, wow. I didn't realize that this tool is this smart. It tracks the organism, or tries. See that? That's cool. That's neat. There you go. That's the motion I was talking about. The airplane propeller motion. I think that's really neat. It's just counterintuitive to how I imagined flagella would work, and how they were depicted to me in a cartoon as a child, which we don't really we should take time to acknowledge how important cartoon depictions are to the like inherent assumptions we make about the world. You see it all the time. I mean, it influences the way that we think in a way that you can't really appreciate until it's exposed to you. That's how I feel about certain, when I read science fiction and I'm exposed to prejudices that I didn't even know that I held. Ursula K. Le Guin is a wonderful author at doing that. She's amazing at opening your eyes to prejudice you held, you didn't even know existed, because it was so foundational to our worldview and to the way that we live our lives that it just is. Ideas like possession or gender. Because they're fundamental ideas to our everyday lives. And so being fundamental, we can't be, usually can't be asked to actually think difficultly about them. Why would you do that? But anyways, got into a discussion recently with somebody on the internet, if you can believe it. I don't want a cover slip. We're talking about the ancient aliens things. I'm a skeptic, but I'm also a student of history. And I got into it with somebody because they were pushing the ancient aliens. And they were saying people just there's no way we just can't understand how they did this. We still don't know how these ancient peoples were able to make these great monuments. And I had to slap the shit out of that. I said, "No, shut up. Shut up." The notion that we can't fathom how these ancient peoples created these monuments, believe it or not, is founded in a racist worldview. And this is where the person got upset. Oh, no, not everything is racism. Blah, blah, blah. This is so sensitive. No, not everything is racism, but a lot of things are racism. A lot of things are racism to the degree that we don't appreciate it. So let's talk about ancient aliens. Why is it racist? Why is ancient aliens a racist idea? It's racist because it makes a couple assumptions. First off, it makes the assumptions that indigenous peoples are incapable of creating great works. They're dumb, they're foolish, they're animalistic, they can't do it. The reason that that worldview came into sense was because indigenous peoples weren't recorded until Western Europeans, white people, came and started recording them. So white people show up to this backwards tribe of savages with their dark skin, and they see these massive monuments. It's unfathomable. How could these inferior creatures have created something like this? Somebody must have helped them. Something must have helped them. They had to have had help because they're incapable of doing it on their own. It ignores so many fundamental facts about human experience and human evolution. The number one, you and I are physiologically indistinguishable from humans going back tens of thousands of years. The ancient Egyptians were just as smart as you. Some of them were definitely smarter than you. The only thing that we have that they didn't is education. Better education and better tools. But they had the same brains that we do. They weren't cavemen. They weren't any dumber, even in the slightest. They were very smart people. And you know what else they had that we don't? Time. Not a one of those ancient Egyptians had bills to pay. Well, maybe they had bills, but you know what I mean. They didn't have Verizon bills, and you didn't have 100 bills. They didn't have jobs like we do, 9 to 5s to worry about, 401ks. No, they generally just had their families and the betterment of their society and their culture. And they had time, and they had a long view. So they could say, let's start this 3,000 year building project. What is this? Am I crazy? Those weren't there before. Why is it more probable aliens from space created these things than the indigenous? It's a huge reach. In so many ways, it's a huge reach. It's an unacceptable reach for me. I won't ever make the assumption. Because, yeah, it does. It divests ancient indigenous peoples of some of the greatest achievements ever to be wrought on Earth. These monuments that have withstood the test of time. Hello, nurse. Now those look like radiolarians. Do you see what I mean about more internal structure? There's an outer shell and an inner shell on these things. Diatoms, are you still here? Can you tell me if that's a radiolarian? Because that, I thought, was a helio up here, but now these guys are drifting out. Look, it's already got something caught. It's already got dinner. Oh, please, let's watch you eat. I wish I had better optics so we could really see the furs on it, the hairs. I can't tell if this is being, working its way across the face of the object or if it's actually getting pulled in. Hard to say. Oh, tiny diatom. Oh, and I should have added to that a little bit more when diatoms and I were talking about diatom reproduction and how they get smaller every time. That's a little fact there. It's important to know. Diatoms never, they don't get bigger or even stay the same age with each generation. Each diatom, when it reproduces, breaks itself in half, and so the subsequent generation is half the size of its previous one. They get smaller and smaller. So when you're panning around and you see a tiny diatom, you know it's an old one. The smaller, the older the generation. Wow. About, what is that, 40 microns? Is that what we figured out? Four microns across. 4! How cool is that? Itty bitty living space. Wow. It's crazy. I wonder what all these other little guys are. Little ciliates. It's so hard to tell. Yeah, no, I don't get down with that ancient aliens bullshit. It robs humanity of our greatest achievements. The greatest monuments to ever appear on the face of the earth were created by humans, for human reasons. It makes sense if your goal is to dehumanize a group of people in order to colonize and genocide. You'd burn and pillage and rewrite their history by framing them as primitives, and I think we're still feeling the effects of that today. Very much so, Mold. We need to revisit our understanding of the past with our new understanding of the present. We, just for example, when Europeans first arrived in the United States, in North America, they found that the natives were living in apparent abundance and plenty, but they couldn't understand. They couldn't understand why. Because they didn't have agriculture, they didn't have factory farming, they didn't have industrialized agriculture the way that Europe did. So how could all these people live in such abundance? And they looked at the forest and they saw that the forests were teeming with life, with game and fresh berries and food that you can just forage straight out of the land. And to the European eye, the natives of this land lived in an Eden, a blessed place. God had given them all the bounty they'd ever need. To the Europeans, the natives were indigent, lazy, sloppy. They hadn't earned anything they achieved. God had just given them this plenty, and how dare they take it without even knowing who God is? Wow! There goes that Rodifer. I thought he swallowed up that diatom. That'd have been awesome. Look at these tiny guys. Diatom, big diatoms. Big diatoms. Anyways, yeah, so they show up and they see the natives there living in abundance, walking through a forest with paths lined with berries and fresh and big healthy game everywhere. What they didn't realize is that they were looking at thousands of years of permaculture. The natives had carefully cultivated their lands, planted companion crops. They cared for their forests in such a way where they could just live on the land in harmony. They didn't have concepts of ownership and possession. I know Louis C.K.'s canceled, but he has a great joke where he talks about how when the Europeans first came to America and they were starving and they were begging for help from the natives, and the natives would show them some food, and then the Europeans would be like, "Oh my God, can I have this?" And the natives would be like, "Well, we don't know what have is, but yeah, I mean, you're dying, so you should eat. You shouldn't starve. I'm not sure what you mean by have, but take. You shouldn't die." And
And the Europeans were like, you stupid fucking assholes. Thanks. And it definitely impacts the way that we view the world to this day. What a bunch of filthy commies. No kidding, right? Imagine. It's funny because we came back to that because I was just talking about Ursula K. Le Guin. One of my favorite novels by her is called
Little
The
hands, this is time
Dispossessed.
to rock and roll.
Hey, Nico
Bring the
Delolies. Nico Daloli. Thanks for the follow. I appreciate you. I was just talking about Ursula K. Le Guin, fantastic sci-fi author. So there's 2 books by her that I really recommend. I wish I could make everybody read. And both of these books so fundamentally changed some of my worldviews. Not my beliefs, but my worldviews. It changed the way that I understand how we relate to certain concepts. And I'll run them down for you. The first book for that, for me, was... oh, you made something for me? Nico Dalolies? What is this? I think I know what you've done. You know what I've got? You got me. Nico. You. Oh, you. Anyway, Ursula K. Le Guin, author of, first we'll talk about The Dispossessed. It's been a while since I've read these, so I'm not going to be able to give you like a storyline synopsis, but the thematic impact of The Dispossessed was major. The Dispossessed takes place in an alien world where the main world is basically a very Earth-like analog. It's a capitalistic society with, you know, city-states and nations. It's very much like an Earth. Think of Earth. In this story, though, the moon of this world was a former prison colony that then became its own society, a la Australia. And in this society, it was 100% communist, to an alarming degree, to the point where families don't even have their own kids. You reproduce, and your child goes to the state living facility. So it's kind of a chilling society. Good morning, baby. But in this society, she explores, because she wants to explore a state of total lack of possession. Total dispossession. And so these people, even in their language, this dispossession is represented. So if you had an injury to your hand, you wouldn't say, my hand hurts, because you don't have a hand. Even your body belongs to the collective. So you would say, the hand gives me pain. The hand gives me pain. The pain is yours. But it's a wonderful book, and she does such a great job of exploring these nuances of the philosophical ideas of possession and ownership. What does it mean to possess something or someone? Are there things that you can never possess, no matter how tightly you hold them? It's a wonderful story. But I came out of that book, having read it, with a different, deeper understanding of those concepts, of what it is to possess. And she explores those notions on multiple levels. So, like, do I possess my wife? In what way does she possess me? Do I possess my home? Can I possess my child? I don't own a person. You can't own an individual. So that was a very interesting read, The Dispossessed by Ursula K. Le Guin. And then by the same author, and on the same token of assaulting notions that you didn't even know you held, I would recommend reading the story, The Left Hand of Darkness. This one almost more so than The Dispossessed. The Dispossessed is more of a sociological and philosophical exploration of ownership and possession and capitalism and communism. The Left Hand of Darkness is a moving and powerful exploration of gender and gender relations. It takes place in a world where the native peoples of this world, they're kind of human-like, except, oh, there's a stentor in a gelatin case. with a rotifer hanging out next to him. Let's watch this guy extend. Oh no, that's not a stent. This is one of these stationary ciliates, I think. It's a single-celled organism that's going to extend out of this little bell, and I think it's going to wave its ciliates. But let's see. Let's watch it for a minute while I talk about the left hand of darkness. So in the left hand of darkness, the peoples of this world, they live their whole lives in a hermaphroditic state. They are genderless, completely genderless, except they have sort of an estrus cycle. So they reproduce by going through this cycle where, I forget the word, I think they called it chemer. But when one of these organisms is reaching the peak of their cycle, like the clownfish that we talked about earlier, there's a feedback in their environment. They're able to sense, or their body is aware of the numbers of males and females, population levels, availability of food. Is the ecosystem going to support us more? And based on these influences, a certain number of these organisms in a community will become female and the others will become male. And for this period of time, they reproduce sexually. There's the thing I was talking about. What's that? I'm noticing these rotifers in this sample only have this extra thing dangling off the side. What is that? I don't know what that is, but there's a little extra something there. Anyway, when I finish the left hand of darkness, it just changes the way you think about basic things like gender. It's a very, very beautiful exploration of the concepts. I really recommend Ursula K. Le Guin as an author in general. I wish I knew what this is. The spinning bit is extremely mesmerizing. That's why they call that a rotifer. Rotifer coming from the Latin meaning wheel bearer, because it looks like it's got a wheel up there. If it turned towards us, you would see it's actually as if two parts. It's not just one wheel on its head. It actually opens its mouth. Oh yes, please, babe. Brioche toast. And then this guy oozing out. Oh. Did something just happen there? What's going on there? You see this quivering and motion happening there. Interesting. So many diatoms, though. Diatoms attack. If you're still here, I would love to hear from you. I know you say on Twitter you're collecting your diatom army. Are you like acid washing and mounting and preserving these diatoms on dry mounts, like a la Klaus Kemp? Is that how you're growing your army, or do you keep them alive? Crystal caves in Subnautica below zero. Oh, the diatoms do? Yeah. So they don't grow like crystals. Oh, speaking of growing like crystals, I thought of something fun we could do with the microscope. Since the light can evaporate this small volume of water rather quickly, I was thinking it'd be fun to create a highly salinated solution. Look, there's the thing again. All of these rotifers have this extra little dangly bit on their head, and I don't know what it is, but I haven't seen it on any of the other rotis and the other samples I've taken. I don't know what it is or what it's doing. So many diatoms. You can't do arrangements. It seems like an insane level of skill. I mean, I'm assuming you've seen Klaus Kemp's artwork. And apparently diatom art goes back to the Victorian era, in the early days of optics. What? S rank on our island? Good stuff. You have a micro manipulator, but not that sort of skill. Yeah, I want to know more about the tools that Klaus Kemp used. I think it would be so fun to even learn to try to manipulate a single diatom. I gotta know what this extra little that is a feature that I have not seen on any other rotifer. Is this little dangly headpiece. Well, that's a diatom stuck on him, but just in this sample. So diatom's attack. Maybe you can help me here. Is there an easily explainable reason for this clustering? Is this a part of that reproduction you were talking about? Because they look joined and clustered, which you don't often see. And I'm wondering, as a, with its silicate shell, how does that work? Klaus uses a modern micromanipulator. Okay. I love his. His work is incredible. Kaleidoscopic. It's a colony of stalked diatoms. Okay. So they always are stalked like that? They don't like break off and turn into a free-floating diatom? Or are they always stalked like that? There's a rotifer just pretending to be a vorticella. I love those guys. Some of these rotifers are so content chasing their food down and running around all over the slide. And then others, they just anchor and they sit there and they just cuddle up with the vorticella and just hang out. I love that. Let's take it back a step again. There's another one. I feel like the longer I've looked at this sample, the more objects have sort of, revealed themselves. I wonder if things sort of just spread out as time goes by. I love these little ciliates. I think they're so charismatic. They're little leggies. But that's not the... radio. There you are. Radio or helio? Five microns. They have a set of small holes on one end of the valve called an apical pore field, in the old days a jelly pore, that they used to exude materials to create a stalk. The colonial stalked diatoms usually just stay attached, but many can move and reposition themselves if needed. That's fascinating. Let's get a closer look at a colony of them then. So they can reattach themselves if need be. What is that? Hang on. That is something else. Not a rotifer. Not a ciliate, but it's something. There goes a diatom. I love the ones that move. Now, do they move by... I'm guessing they have the cilia just like any other thing, and they sort of walk around that way. This thing is a something else, though. I'm not going to be able to get enough light on it. Can't tell. You can really get a good look at it this way, but it's a larva of some kind. It looks very firmly affixed to the surface of this algae. I can make out some complexities there. You grew your own purple flower, babe? Hooray. Nice. Oh, they do not have cilia. They have a structure like a slit that goes through the valve called a rafe. They push and pull materials through the slit to drag themselves around. By what mechanisms do they push materials through the slit? Is it like a capillary action? Can they constrict the slit? Is there any motion at all in there? That's fascinating. That's really interesting. Because I was imagining that they just had, oh, that thing just moved. I was just giving up on it being a thing, but now, oh, it's just got a much harder shell. It really does look just like a stentor, but it seems like it's not quite the same as the others. So they got a rafe. They push and pull materials. So almost like a jet, right? Got a nice head-on view of that one. So pretty. Can't get enough of them. More Helios. More like a snail. Okay. I mean, at this scale, like the mechanics, the physics of how these things are able to move, it's just so different. I'd love to know more about like the delta P that some of these organisms experience when you drop a cover slip on the glass. And you've got that volume of water suddenly constricted in between the two pieces of glass, and gravity's pushing the glass down, and surface tension is sucking the water out to the sides, and you get, I mean, the currents that you can see inside, if you drop the slide on and then look at it, it's pretty wild. This music, isn't it? You better not be on the chill playlist. I don't want no dubstep on my chill playlist. And gamer dubstep too. Yuck. Diatoms, we got rectangles, we got diamonds, we got circles. Hello. Alright, I gotta go arm my wife. Just a moment. I'm gonna turn it this way so you can see the dog get mad about this too, because my dog hates it when we get armed. Parm. Here we go. She was aiming for the balls. She always aims for the balls. And my dog is a non-violence. He's basically like an activist. Like if he sees us loading and pointing the Nerf guns around, he immediately gets angry. He's very upset about that. No violence, please, he says. Parmesan, the non-violent crime dog. I love these little guys. Norman is a monkey. I saw on some microscope website someone was talking about the the flagellar motor, or whatever. There's it's the little motor that enables the flagella to whip and spin around in the way that it does. And I actually took a screenshot of this. Let me see if I can find it, because it was pretty stupid. She was claiming that it causes issues for evolution, which I hate that when people are like, look at this amazing thing in science and nature. It's so complex, it's been causing issues for the theory of evolution. No, it fucking hasn't. Every time you think you're causing issues for the theory of evolution, you're providing more evidence to support the theory of evolution. Keep trying, creationists. Fuck, it's just tired of it. Ooh, this is really complicated. Scientists are baffled. Anytime you see a headline, and the headline said, scientists baffled by X, it's bullshit and a lie. Scientists don't get baffled. They get fucking excited when something is surprising. If something is completely counter to their expectations or predictions, they don't get baffled. They get jazzed. They get thrilled because they're on either catching themselves in a big mistake, or they've discovered something new and compelling. The state of science journalism is absolute fucking garbage. They were really gigging it, weren't they? Because they're caught here. It's a fabulous night for a moon dance. Oh my god, he's trying to... You can't eat that. You can't eat that, Roddy. He's trying. He's trying to eat it. Oh my god. He can't eat that, though. I'm pretty sure he can't eat that. There you go. You had to spit it out. I wish that we could have better science journalism. Because the current state of science journalism is why we have anti-maskers and anti-vaxxers. The fact that Dr. Rashid Buttar, who is not a doctor, he's an osteopathy, I forget what it is. It's a woo pseudoscience where they pretend to heal you of your diseases by bending your body. Muscle and bone manipulation is all they do. Osteopathic therapy, it's bullshit. It's massage. It's a complete traditional medicine, and by that I mean modern, made-up, not medicine. You know what they call traditional medicine that's been proven to work? Medicine. They call it medicine. Aspirin is a traditional medicine that was proven to work. It's in fact an herbal remedy. Aspirin. It's a traditional herbal remedy used by woods witches and cunning women for millennia. What else it's called? No. Oh, salicylic acid. Yeah. Is aspirin? Yeah. Yeah. And I put it on my face. It's also plant food. Yeah. Chemotherapy drives me fucking crazy. Or chemotherapy. Chemophobia. Chemophobia drives me crazy. Oh, is it natural? Don't eat it if it's not natural. Mercury's natural. So is uranium. Uranus is natural. There's my cute little cilia buddy. These guys are adorable. They're not as cute as Gastrotrick, though. Gastrotrick are by far my favorite. But look at them walking around. I love how they walk around. In an aquatic environment, it's fun to watch things walk. Oh, Lex, clipped me. Thanks. I don't know. I'm just so charmed by... I'm charmed by something walking. Dancing couple gets eaten and regurgitated by nightmare monster. Very good. Oh, that's another Helio there. Oh no, I was just gonna say, I am instantly charmed by any aquatic organism that walks around. Excuse me, didn't mean to cough into the mic, that's terrible. Any aquatic organism that walks is charming. We found those sharks that plod around the seafloor. Alright. Let's try a new sample. I've got a slide ready. I think we've seen all the surprises in this one. Oh, there's a surprise. Hang on. What's that? Is that... Oh my god, guys. It's a Helio undergoing reproduction. Look at it! Mitosis! Mitosis! That's so cool. Let's just sit and watch. I'm pretty sure that's what's going on there. Diatom's attack. Do you want to give me a reading on this? I mean, cell division is pretty obvious, right? Yeah, look at that dummy ramming into them. Stupid. Oh, how cool. Yes. Amazing. Babe, I got... Yeah, it looks like it does seem to be dividing more and more, doesn't it? How long does this process take, I wonder? I mean, it's visibly progressing now. No. That is cool. I'm always hoping I'm going to catch something in the act of doing something. Whether I got lucky when I got a video of that rotifer taking a visible bite out of something. That was cool. Watching cell division happen. That's a new one. A one I'm very excited about, though. Let's try to recenter this again. Now I wonder. No, I don't want to lose our opportunity to see the actual division complete. Almost. And there we are. Now there's still a bridge. Still connected slightly. That was so lucky. And I literally was just about to pull that slide off the stage. Just goes to show you. A little bit of patience always pays off, right? How freaking cool. Wow. Streamer freaks at creature reproducing live on Twitch. That's me freaking out. Ah, there it goes. Now it's free. That was the moment. How cool. That was very, very neat. Everybody, we just witnessed life finding a way. Mwah. Mwah. Look, life found a way. Whoa, what's happening? What is happening? Why did everything just rush to this? Oh, weird. Something evaporated enough, I think. Oh yeah, we had a lot of evaporation happening on that slide. Well, good job everyone. That was really great. We got some mitosis. There are a lot of these helios in this. This is a great sample. I really like this pond. So here are these clustered diatoms again. What are you? What are you? Air bubbles? Yeah. Interesting though that they are free floating. What's up with that? Usually when I've got an air bubble caught, it is trapped, but those are free forming. Well, Lex, I was so excited. I never thought I'd actually just witness mitosis happening live. Like, just so lucky that we happened to look at it at that moment, just as as the cells were dividing. And like, as I understand it, mitosis happens, like a lot of the process of mitosis occurs before there's any real like visible action. You know, the cell does a lot of internal preparation and division before it actually starts stretching and dividing. So we just got so lucky to capture it at the moment that it really was in a full division like that. That was just flat out cool. And then at that very moment, we had like a vacuum state collapse and enough water evaporated. Usually with mitosis, we witness the process sped up in an animated fashion too. There's usually an animation that shows us, you know, how the chromosomes divide, what happens to all the internal elements which aren't visible to us using optical scopes like this. Give me just a moment to get up, guys. I'm going to start a second cup of coffee because one cup of coffee ain't enough. It's not enough for me. I need at least 2 cups of coffee. Sometimes 3 cups of coffee, depending. So stay right there. Watch this rotifer for a minute for me, please. And also congratulate yourselves for having witnessed cellular reproduction live. That was really neat. And a heliozoan too, no less. Very cool. Scared though because I don't know how to be a best friend, and I was like, "You're already doing it. Like, don't be freaked out now that she told you that because whatever she told you that because you're already doing it. Like you don't need to worry about what to do. Just do whatever it is that you're doing." That's so funny that she's like, "Oh." Yeah, she's like, "I've never been a best friend before." I bought a new dress. a dog a bone time. Yeah, that sounds right. All right, somebody wants to see. Do you want a treat? You guys ready for a dog show? I don't have any ponies, so it's just a dog show. Japo NXL, there's your redeemed Give a Dog a Bone. Thank you for joining. What's up? I got my second cup of coffee on the boil now. So I took a good long break from social media for a while. Didn't post on Facebook, didn't even try to figure out Twitter. And then I started streaming on Twitch and realized that I gotta get a little more active on the socials if I want to have any measure of success, and if I want to reach people with the stuff I like to share, then I gotta get out there and push it. So speaking of which, here's my socials. So because of that fact, I've been encountering more people on the social media and addressing things in my own way. I don't know what you are. Huh. That was a new one. Never seen that before. Lex. What's up? But anyway, somebody posted some... Oh yeah, I'll look at it. I'll give you my opinion on design. Let me continue my rant here. I was talking about how on the Facebooks, somebody posted a coronavirus update and said this many, here's the number of cases in the United States. We're up to this number now. I forget what it was. And somebody commented, except those case numbers aren't even real. And so he said, citation needed. And she goes, it's all these nurses and doctors are creating these undercover videos, and all these whistleblowers are coming out saying that the coronavirus numbers are fake. They're faking the numbers. Are they? So I asked her for some sources. Started going through the material she provided. And I spent a good long while. I wrote a number of paragraphs systematically addressing her points, systematically addressing her claims. And it came down to her citing sources from news articles that claimed the exact opposite of what she was saying. She would say, look at this news article. It says that hospitals are faking coronavirus cases so they can get more money. Okay? So I said, well, show me the evidence of this claim. Let me see it. Okay, here's the evidence. It was some guy went on Laura Ingram's show, which if you know Laura Ingram, she's a disgusting troll. Went on Laura Ingram's show, and he said that it is possible for hospitals to get more money when they have coronavirus cases. So if they have to ventilate a COVID patient, the hospital is going to get more money from the federal assistance programs because it costs money to ventilate COVID patients, and the federal government is providing assistance to the states. Okay? All that is correct. So if somebody makes the claim that says hospitals get more money for coronavirus patients, yes, that's true. And they should. There's nothing wrong with that. The problem is that the claim doesn't stop there. They're not saying hospitals are getting more money for corona. No, what they're saying is hospitals are making up thousands of coronavirus cases out of greed so that they can get more money for a pandemic that doesn't exist. And that is a claim that I cannot allow to be made. I will not stand by and let somebody make that claim without being challenged. And so I challenged the shit out of her. And the troubling thing is that it came down to the fact is that she would show me a source. I would interpret it accurately and say, this is what the source says. And then she would say, no, it doesn't. Okay, let's try another one. She would give me another piece of evidence, and I would sort through it and say, actually, this is what this piece of data is saying. And she'd say, no, it doesn't. You're wrong. So at a certain point, I then stopped addressing her, and I addressed everyone that was reading the comments and said, to everyone else, you have to understand, science literacy is not an education gap issue. You cannot teach science literacy. It has to be a way of thinking, a way of remaining actively curious, challenging yourself. Science and literacy comes down to a deeply personal issue for people, where one's intelligence is wrapped up with their pride and vice versa. And to accept that you don't understand something or that you were wrong about something is equivalent to taking a massive blow to your pride. And for many, many reasons, people can't do that. One of those reasons being something like the sunk cost fallacy. Once I've spent so much energy promoting the plandemic conspiracy theory, which is one of the dumbest fucking things you could spread. It's dumber than the fake moon landing. If you've spent all this energy spreading a utterly foolish and shameful ideology, to then take it back, to admit that you were wrong, and to begin undoing the damage that you've done, that hurts. It hurts your pride. It hurts your vanity. It hurts your sense of self. It becomes almost impossible for people to do, which is why it's hard to get somebody out of a cult. Because to leave a cult is to admit you were wrong, is to admit you've wasted so much time. Not only that, but you were bested. You were fooled by others. And that hurts. But if you push through the pain, I've had to do this. I've had to push through so much of my own pain of being wrong. When you push through that and you internalize that you were wrong, how you were wrong, and why you were wrong, then you come out the other side a vastly improved person. You're better for it. And this is whether you're admitting you were wrong about the plandemic or admitting you were wrong about that thing that you said to your significant other. This kind of intellectual honesty is painful, it's slow, and it's difficult. But if you apply it to every corner of your life, you will find improvements to your character, to your well-being, to your esteem in others' eyes, to others' esteem in your eyes, because you'll be leading by example. You'll be setting an ethical example, and the people around you will be influenced by that as well. All these tiny changes that we can make just in the way that we think about ourselves and think inside of ourselves, they can immediately impact the external. That's another spiky guy. Funny shape. Hard to get a read on that one. It's in the weeds. What is this thing on the rotifer? What is that thing? I keep seeing this thing. Alright, so if the rotifer is 15 microns, that means that this thing is only going to be a couple. A single micron. Do rotifers have antenna? Never seen a rotifer with antenna. I don't know what that is. It looks like an eye stalk. But a rotifer doesn't have an eye stalk. I'm not even sure if rotifers have... They gotta have a light sensor. It's for a friend's Discord. Do you DM it to me on Twitch? Or on Discord? I see Discord. Cool. Oh, I like that. I like you've got the nautical star in the center. Rotated like 13 degrees off. Interesting. So you don't want it standing on its point and you don't want it standing on its 2 feet. What is the significance of the tilt on the star there? Because that's the first thing I notice. Like, to my brain, the first thing that stands out to me is the orientation of that star. It's not your typical point straight up, and it's not your point straight down. It's a little off. I like the embossed quality you have on it. The background image is great. It's a good logo. It's a good logo. Here, let me show it to everybody. Is that cool? Lex just designed this little guy here. There's no meaning behind the orientation of the star. Okay. It stands out to me that it's a little rotated. Because at first I thought it was pointing at these objects. But they're not. But this is still nice. I like the nautical star, the olive wreath. Classic. It's a good design, and I like it's embossed, it's raised, but kind of translucent on the edges. It's good design, Lex. Certainly better than I could do. No doubt. Here's its antenna thing again. You damn antenna having rotifers. What gives you the right? If anything, it represents that there's no up in space. That's right. That's right. A true spacefarer would look at that logo and just automatically orient to whichever direction he feels. Truth. My coffee is done. Just a second. Let me give it a pour. So I've been thinking for a while, trying to find some excuse to do a backyard stream. I think it'd be fun. I can do intermittent archery while I work on a woodworking project, or do, create this biome. That'd be fun to build a marine biome so I can farm my own organisms. So yeah, I've been thinking about different ways, different things I can do in the backyard to fill a stream. The problem is, my backyard is very long. It's a long yard. And my internet doesn't go all the way out the full length. So if I do a backyard stream, I'm going to have to set up my laptop and cameras and rig right here at the back door. And you'll have a shot of my yard. But say if I shoot an arrow, you're not going to be able to see if I hit the target. Or at least not well. There is no true orientation. Everything is relative. This is very true. There is no true orientation in any matter, for that matter. We need to learn to stop thinking so digitally. Most things exist on a continuum. All right. Back to this scummy sample here. I wonder... if we got anything swimming in here. Just a second. This Spirogyra algae that comes in this pond here is so fine. It is thinner than a hair. It's about 16 microns across. Stunningly small. Actually, I want to let this dropper settle a little bit. I'm going to set that down and let the silt fall to the bottom a little bit. You made a new Discord profile pic. I saw that. The Discord profile pics are always so small. Fleet Admirable Lexington. Can't quite make out the last word there. Custom status. You can set custom statuses on your profile? Oh, I might have to do that. I like writing custom statuses. All right. Yes, some silt has gathered at the bottom of this slide now, this dropper. All right, I'm going to go ahead and put a cover slip on this one, though. Because I think it's going to be fine. Nope. Too much grit. God damn it. I hate when that happens. Yeah, you can send me a larger one because I can't quite make out the whole bit there. I'm going to start calling these unicorn rotifers. Hey. Hey. There we go. Finally, one of these guys that's not all clumped up. Oh, Lexington Danian. This is what we were looking for, guys, right here. Because earlier, we saw one of these that was severed, and I thought it was a helio or something, but it was caught in a Vorticella colony. And the second one we saw was completely clumped up in a whole chunk of Vorticella colony. So I couldn't make it out at all. Finally, we've got one of these organisms by itself. Still don't know what it is, though. It's got this heart shape. And it's covered in spines like it's a helio or a radio. There it is. There we go. Yeah, I don't know what that is. It's kind of pretty, though. You can see this. There's a stream or a current. I think these are probably nutrients of some kind. They're just leaking off of stuff. This is what these organisms really want to be eating. There you go. See the currents? I wonder if we can follow that stream. What's it coming from? Oh, it's like exhaust from the Vorticella. Because they're drawing all this stuff in. Can I draw? I can draw. So is the Vorticella... Oh, I have to click twice, though. Lame. Are the kitties cuddling you? Oh, Starfleet insignia. Nice. You can follow the stream of nutrients in the water. I don't know if you guys can see it on the stream or if compression blocks it out, but there's like a little cloud here. And you can, it's a current that's slowly
dispersing. Yeah, Fleet Admiral. I hope that's the rank that you assign yourself. I'm just kind of following these nutrient currents here. I'm guessing they're nutrients. So many pretty ensign. Yeah, that'd be pretty good. Purdy. Is this? It's got to be attached to something else. I wish I knew what this was, though. We'll identify that. That's my next objective, is to identify what this heart-shaped spiky boy is. Let's take a look at it in dark field. Alright, same coloration as the Vorticella. No coloration. And where'd that flashlight go? Diatom check. There it is. Top of the frame. Trying to get this light to shine on it the right way. Huh. Yeah, right. Huh. The crossfield class. I designed an image. I'm just proud of, I mean, I just learned how to use GIMP and do a couple things recently. So I made this schedule page, which is my offline image, which I'm proud of. I've managed to find a way to warp. I use the cage transform tool to kind of bend these text columns to fit the algae picture. And it's fun to use an image that I made and all that. That was a neat little project. All right, I'm going to go grab my coffee. Dude, I use Notepad for so much. Is that visible? Well, not behind the chat though, is it? There we go. Classic. Do you have too many flowers? No, we have covered the entire island with flowers. Alright, I'm going to take the dog out. I'm going to get my coffee. It's there, but I got to drink some of it. Stretch my legs. We've been doing Wow, I've been doing this for 3.5 hours this morning. Time flies when you're looking at microbes. Flies. Alright. Batman doing an ooh face. Okay, you're going to have to share that with me, Lex. You're going to have to share that one with me. Alright, I'll be back in less than 7 minutes. I just gotta walk around for a minute and take the dog out and be cool, honey bunnies.
Hey, I'm back. Hey, Lippersync. What's up? Oh, let me catch up on chat. What's up? Oh my god, Las Plagas! Oh fuck! Las Plagas! Resident Evil 4 is my favorite Resident Evil game. In fact, that is the origin of my handle, Del Maximum. Resident Evil 4 had one of the scariest monsters that I'd ever fought in a video game up to that point. Del Lago. Remember Del Lago? Del Lago translates to of the lake. Let's look at that clip. Something swam past. Thanks for clipping that. Let's see what he saw. Oh, that. I think that is what's called a swan tear. They're called swan tears. Here. Put that here so you can see. Yeah, that thing is called a swan tear. Let's look. Swan tears. Lacrimaria olor. Yeah, that's definitely what we're looking at here, right? Lacrimaria olor. Long neck, mouth at the end. There's, wow, look at that one all stretched out. That's definitely what we're looking at, though. I'd never seen them so long. These look like my pictures. It's kind of refreshing. Like, sometimes I get down on my own quality of the images that I take, but then as I look at pictures on, you know, these look like my pictures. This is the same quality I'm capturing. What we're looking at is a bit of fresh water from a local pond. Oh my god, look at you stuck in a vortice. Oh, you poor Vorticella. Ah! He's doing this to himself, I think. What we're looking at is this Vorticella's moving his cilia around. Yeah, so we're looking at jars of pond water. So I just went to some local municipal ponds and I collected a few samples. So a clear sample, I got a mucky sample full of Spirogyra algae. We can look at some of those. It's a really pretty algae. And so in here, though, we're looking at a lot of different organisms. This, I forget the name of this ciliate that uses its flagella out in front of itself like a whip. I don't know what this spiky thing is. It might be Las Plagas, though, now that you mention it. Holy shit. Over here is some algae. Earlier, we witnessed a heliozoan undergoing mitosis, which is extremely lucky. I did not anticipate being able to see that event happening, so I recorded that, and I'm sure we can get a clip of that later too. I gotta go and do a couple highlights of this stream tonight. Alright, so I'm gonna just grab a picture so we can identify this thing better later, because it's hard to ID. It is... Oh, that's okay. Mitosis is a method of reproduction that single-celled organisms undergo. And it, basically, it's where the nucleus divides. Let me find a cool GIF of it. It's single-celled reproduction. So what happens is the cell basically doubles its DNA, and then it divides itself along these lines and sends its DNA to its new partner's cells, and then it has two daughter cells. It's how one cell makes itself into two cells. Asexual reproduction. And so we witnessed a heliozoan, which is a really pretty single-celled organism, going through this process. Yeah, it's a long process. So here you can see them stretching and stretching. It took a few minutes, so I didn't record. Oh no, I just crashed my software. It took a few minutes, so I didn't record the whole event. Now this guy right here, that's a diatom. These are really special organisms. They're single-celled algae that are extremely unique in that they create their own glass houses. Literally houses made of glass, silica. Diatoms represent a significant percentage of Earth's biomass, as well as producing over 35% of Earth's atmospheric oxygen every single year. These little tiny single-celled organisms are the second lungs of the Earth, where the Amazon is the first. But the oceans, filled with gigatons of biomass of diatoms, and every freshwater channel, they live in dry land too. And every year when gigatons of these diatoms die, they sink to the bottoms of their marine environments, carrying with them sequestered atmospheric carbon. So not only are they an important part of Earth's life cycle by being a foundational feed species for a lot of other organisms, they also serve an important role in Earth's climate. Very important role in Earth's carbon cycles on the climate scale. Over tens of thousands and hundreds of thousands of years, Earth's atmospheric carbon has been regulated by organisms such as diatoms. Diatoms are special though because their bodies are heavier than water, so when they die, they sink. Their carbon is not reintroduced into the atmosphere or into the ecosystem for hundreds of millions of years. It sinks down and becomes the sea floor. You can buy these in the form of diatomaceous earth, which is basically just crushed up diatoms, literally just glass sand. They're very special creatures. They're also exceptionally beautiful. I wonder what it would look like if you took all the diatoms in the world and stuck them in a sufficiently large pile. It'd look like that. That's a pile of dead diatoms. That's literally what it is. (20 to 25% of the oxygen we breathe on Earth). They appear in so many different shapes and forms. These are all diatoms. Here's more diatoms. Here's even more diatoms. In your normal treated city water, you shouldn't see any of these organisms. They won't survive your normal municipal water treatment. We chlorinate and work our water. They're so pretty. There's a wonderful artist by the name of Klaus Kemp, and I always show people Klaus Kemp every chance I get because he took a Victorian style of art. So this was being done in the Victorian era. Oh, his website's down. But this guy, by hand, he picks up diatoms, washes them, cleans them and dries them, and then mounts them on a slide, each individual diatom being placed. And then he photographs them. And these are all dry mounted, so not only can he make a print, but now he has a slide that's just basically a reproducible print. They are geological. They are geology, but life creates geology. Have you ever seen stromatolite? You want to talk about life creating geology? Stromatolite is a really interesting thing. So let me just go to the Firefox view here so I can show you this. Stromatolite is really neat. So it's a layered biochemical accretionary structures formed in shallow water by the trapping, binding, and cementation of sedimentary grains by biofilms of microorganisms, especially cyanobacteria. So what happens is algae and bacteria will grow in these colonial mats in layers. And you'll have a generation of cyanobacteria that will be collecting sedimentary grains. And then another generation of cyanobacteria will grow on top of that layer. And then more sedimentary grains. And then another layer will grow on top of that. And then more grains, and then layer, and then grains, and then layer, and then grains. Over hundreds of millions of years, you can get these colonies. So here's modern stromatolites in Shark Bay in Western Australia. This is what it looks like. These are all colonies of cyanobacteria or other microbial mats that have slowly been layering and building up over years. Over millions of years, these stromatolites, well, it's not stromatolite until it's a rock. So once it fossilizes, it'll turn into stromatolite, which you can see form these really interesting whorls and shapes. So here's fossilized stromatolite that's been embedded in a layer of earth there. Oh, it reminds you of Elite's metallic crystals. Yeah. Yeah, they're really, really pretty creatures. I'm pretty enamored by them. Look at that rotifer. What do you think of that, Lippersink? This is a rotifer. You see its organs. I think that's an egg, maybe. Oh, I didn't see the Batman. Let me see the Batman. Oh, I love it. Oh, let me put this back. Here, this is what I was trying to show you. Lippersink, yeah. This is the rotifer. This guy right here. Rotifer can come in so many different shapes and sizes. They're very diverse organisms. They can all be rotifer. Right now, I think it's trapped in between a few layers of this algae. Normally, they sit there and they eat, or they swim around and they eat. Yeah, this sample is drying up, so we're going to burn it. Get rid of this sample. Now let me pull a sample of some Spirogyra algae so you can see the internal structure on this, because it's a really beautiful type of algae. So let me just pull some of it up, and I gotta snip some. It's so fine. Each strand of this algae is no more than 16 microns across. So it's incredibly fine. Just thinner than a human hair. I think it's suffering. That's why it was undulating, because it's the water that it was in is being heated and evaporated very rapidly by the light of the microscope. I think that's a problem for it, and it was not enjoying the sensation. Oh, the big worm, today's big worm. Here's today's big worm. You can see all these little organ, like this activity, this pulsating inside. It's disgusting. I love it. And I think these might be little eggs, these little round parts in there. I don't know. Some kind of worm. I don't know what kind of worm. Let's see here. I'm going to try to make this sample interesting. I'm going to attract some organisms. So this is a trick that was taught to me by Pacific Plankton. You can see here I'm shining a flashlight into the side. You think that's what that is? It might be stabbed. It might just have a diatom stuck on it. I saw what you were looking at right there. Maybe. I saw it move a little bit. It might just be stuck on its side or kind of attached to its spine. I don't know though. Right now I'm shining a light into the side of this, and all of the ostracods and cyclops, or rather Daphne and Cyclops, are all swimming to the place where I'm shining the light. Hopefully. Suck up a few of those. Alright. So I got a few larger animals in this volume of water here. I'm going to let that sit vertically for a while so that sediment can fall to the bottom. Maybe some ostracods will come to the top. I wonder what that an organism like that, what is its sensation of pain? Does it have pain receptors? What is its central nervous system capable of transmitting that kind of signal? I don't know. Somebody knows. Alright, let me just get a little bit of this Spirogyra. Okay. I'm going to need to do a little bit of work on this one because currently I've got a larger organism in there. I'm pretty sure it's a big Daphnia. And if I just drop the cover slip on top of this, it's going to crush that Daphnia. And remarkably, it will break the organism. It'll break the Daphnia. So what I need to do is an interesting trick. I'm going to take a cover slip and I'm going to snap it in half. Okay, I just made a bunch of shards. That sucked. Okay, these shards are razor sharp. Let's be careful. Let's try again. I need a softer. I could try cutting. These cover slips are actually thicker than my other ones, so that's a problem. Let's try this skinny one here. It is a tissue. Come on, get on there. Alright, hopefully this won't crush our baby here. Actually, I'm gonna try to put on another layer. So you can't even see what I'm doing, but I'm taking tiny shards of glass and I'm stacking them. I'm trying to stack them up so that when I put on the cover slip, it won't sit all the way down on the surface, and I'll be able to have it be propped up some, and I won't be crushing the larger organisms on this slide. It's very easy. They're so delicate. Alright, closer. Closer. I know it's not the most thrilling thing to watch on stream. I wish I had a nice close-up camera so that I could show you what it is I'm doing here. I'm holding a piece of glass and the end of these tweezers and using it to push another piece of glass across the slide. Lippersync, don't apologize, man. This is why I'm doing this here, so I can show this kind of stuff to people who don't normally see it or aren't normally exposed to it. I'm glad it's out of your expertise. I love having experts here who know more than I do, but I'm also very comfortable and happy to share what I do know and understand about this stuff with people who don't know it. So never hesitate to ask questions. Never hesitate to display your ignorance, because without displaying it, it will never be filled. Ignorance is just merely a gap of knowledge. And unless you're unwilling to fill the gap, then ignorance is nothing to be ashamed of. Oh, I did it. She's swimming around in there. I got some air bubbles, but I didn't kill this Daphnia. I'm guessing it's a Daphnia. Let's take it back a step. Where'd she go? Oh, it's an ostracod, not a Daphnia. Ostracods are really neat. They are related to mollusks. It's a shelled organism, little animal. Come back. They're fast, these ostracods. So it lives between two shells. It's like a freshwater shrimp that lives inside of a shell. So the only thing that ever leaves its little shell are its antennas and its feet. Let's see if we can look at what it looks like in dark field. So now we're going to shine a light on top of the organism, and you'll be able to see. See, it's got a shell, kind of speckled. So it lives its entire life in between these two chitinous shells. The ostracods. It's a class of crustacea. They're also known as a seed shrimp because they have those little shells. They look like little seeds. Their bodies are flattened from side to side and protected by a bivalve-like chitinous or calcareous valve or shell. The hinge of the two valves is in the dorsal region of the body. Ostracods are grouped together based on gross morphology. Blah, 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 blah. We could read the whole Wikipedia article, but no need for that. Fossilized ostracods. Ostracods are by far the most common arthropods in the fossil world, with fossils being found in the early Ordovician to the present. Here's a large ostracod fossil. 10 millimeters. That is a big ostracod. So we captured that ostracod, but I didn't even show you. That ostracod was incidental. Just happened to be in the right place for this. But what I wanted to show you in this sample was not the animal. But let's look at him a little more. He's stuck on that bubble. Surface tension is a goddamn nightmare for organisms this small. He might never get off of that bubble. Seriously, he might never get off. He might never make it. Once surface tension has a hold of you, it's a nightmare. I think he's stuck. I wonder if that's like I know that we're doing some really neat physics and medicine with microbubbles. I read a thing about how they can breach the blood-brain barrier with targeted drugs using bubbles. Microscopic bubbles. This bubble, 8 microns across. Ostracod, we're looking at 19, 20 microns across. Why is surface tension a problem? Has a lot to do with scale and mass. So hey Sarah. Yeah, it's gotta be. I mean, look at it. He's stuck on that bubble. This is something that I want to learn more about, and I talk about this a lot, is as we're exploring stuff in the microscope, we're focusing on biology. We're focusing on the organisms. We're looking at how they're behaving, what they're eating. It's fascinating to look at the organisms. But there's a whole other layer of stuff happening on the glass that is fascinating to me, and that's the physics. The fluid dynamics, the pressure systems, the forces at work, the physical forces at work inside the slide. Really interests me. I'm very fascinated by that. Oh, he's breaking free? He made it! He made it. Good for him. Whoa, that was a baby Cyclops. Did you see that spider-looking thing that appeared in the frame for just a second and then disappeared? It was there for literally a blink of an eye. Let's see if I can find it again. That was a baby Cyclops. Yeah, you saw that, Sarah? I saw that. I love Cyclops. Here, I've got a picture of one. I'll show you what we're looking for so you guys are prepared. Dino flagella. Was it after the dino? Yeah, it was after the dino. This is what we're looking for, guys. That is a larval Cyclops. So yeah, keep your eye out for one of those. That's what I just caught a glimpse of that guy. I want to talk more about your question. Why is surface tension such a problem? Why are those forces so powerful? And I'm not sure if I might want to do more research so I can speak a little more clearly and not fumble through the topic. because it's something that I am constantly asking about as I'm streaming microscopy. What's happening there? What are these forces at play? How powerful is this water current? What's physically going on there, not biologically. Biology is fascinating enough, but again, I want to know more about the physics of this microscopic world. So maybe Lip, I might want to do like some research, and I'll do a segment on surface tension, because there's a lot of really interesting effects, and at this scale, these physical effects are much, much magnified. Boundary layers, currents, I mean, fluid dynamics is chaotic and insane. Veritasium does a really good video on turbulence. Ha, Lex, thank you. I love freaking out friends. This Oshtakot's freaking out, but I want to see that larva. I forget. Julie called it something. If you guys are enjoying this, let me give a shout out to somebody. A Tiny World. She does a lot of this. She's definitely a more experienced hand at streaming microscopy and science than I am. I have looked to her for many cues on how to share this kind of stuff. And then also, Pacific Plankton is a great friend and guide in this stuff. You just came from her stream. Did she just wrap up, or is she still rolling? When I'm live, I can't respond to my notifications, so I don't know. It is a tough world to be in. The microscopic world is a fascinating one. Right, because it's something that, like, it's easy to actively wonder about the mysterious creature that you're looking at. But it's also easy to get answers. You can watch it behave. You can just observe long enough, and some things will make themselves apparent. How does it eat? Oh, there it is eating. How does it move? Well, look at it move. What's that thing for? Oh, it just used it to defend itself. You know, there he is. Got him. There he goes. She did an interview with an environmental scientist who studies lakes. Oh, I should have listened to that. Because I am studying a pond right now. Oh yeah, the spaghetti thingies. This is really what I pulled this sample for. What you're looking at is called Spirogyra algae. It's a really beautiful form of algae. This is the one I was talking about. 16. Oh, this is 2 microns across. Very, very fine algae. What makes Spirogyra special is this really unique helical pattern that its chloroplasts form into. So chloroplast is the organelle that absorbs sunlight. This is what's responsible for photosynthesis in the organism. Terrestrial plants have chloroplasts just as marine algae does. Chloroplasts make the world go round. So these chloroplasts in the Spirogyra algae form into these really beautiful helical patterns. Now, I learned from Pacific Plankton is that there is a really interesting reason for this, and it has to do with a very unique method of reproduction. And I don't know this information, so I'm not going to share it with you yet, but I'm going to learn about it. Let me take a note, because I do want to make sure that I learn this stuff so I can share it with you. Spirogyra algae reproduction. Got to write that down. Because, yeah, there's a reason for this shape. It really is beautiful, which is why I chose it to make my my offline screen schedule. So I took this picture of algae that I had made, and it was fun to use my own image. Don't need to credit anybody but myself. I learned how to warp the text, and I made this new schedule page using this Spirogyra algae. Matt Dark Pro! Oh shoot, that was, what the fuck was that? Hey Matt, how are you, dude? Excuse me. What the fuck was that? There's that larva again. It looked like a cockroach. It looked like a nymph, like a dragonfly nymph. Thank you, Sarah. Yeah, I'm really proud of it. I taught myself how to use GIMP and learned some tricks. There's that ostracot again. But I gotta find that other guy. There was another mega creature in here. Oh, you're in a car. Oh, I'm sorry. Too loud. Read my lips, Matt Dark Pro. Matt Dark Pro is awesome. He's been streaming a little bit more lately, and he also created the stingers that you see when I do my scene transitions, and you see the spaceships whirl past and the raccoon face, and that was all the work of Matt Dark Pro. He very generously just created that stuff for me and helped me set it up on my stream, so I always give love and thanks to Matt Dark Pro. Very kind. Good work, too. I gotta find that thing, you piece... It really was fast, though. I'm not confident. We're just gonna search the perimeter. Matt's not driving. He's a minor. You're not driving, are you, Matt? Also, a car? Don't you live in a place with a phenomenal public transportation system? I would figure you would just be taking those trains and buses everywhere. You live in a civilized world. Can I see this thing with the naked eye? Not a chance. Bothersome. That darn thing. I want to keep hunting for it, but I also know that that's boring. This is how Las Plagas begins. We're going to talk about... Ah, there he is. The hell are you? Daphnia. I think. I just haven't seen one from the top down. It's got enough space that it can just swim normally. See, that's neat. I gave it enough levels. So normally, when I'm looking at a Daphnia, Daphnia are often called water fleas, Lippersync. I'll show you what a Daphnia looks like. I've never seen one swimming vertically, because when you look at a Daphnia and you put it on a cover slip, usually it gets flattened. And so this is what it looks like. And see, it's got this right here. This Daphnia is actually pregnant. Check this out. Look at this video. Do you see these? See the motion? I circled the two locations I want you to watch for motion. Do you see the flickering there? Here and here? Those are heartbeats. This is the mother's heartbeat, and this is her infant baby's heartbeat inside of her. Look at this. Some of the coolest footage I think I've captured. 2 heartbeats. Is it a parasite? No, it is a predator. Yeah, that's one of the coolest things I've ever captured, Sarah. I'm really proud of that video. A pregnant Daphnia and both the heartbeats. But I think that might be a Daphnia. It's moving like one. Stop running away from me. seed shrimp without the shell? No, they never leave their shell. Can't do that. The ostracod. They won't be able to eat the ostracod. They feed on smaller microorganisms, little ciliates and algae and anything it can get. Do they shed them and regrow? No, I think they have short enough lifespans. I think. Let's look. I want to look that up because that's a good question. They might molt, but I know it's a chitinous shell. The body of an ostracod is encased by two valves, superficially resembling the shell of a clam. Is he trapped? Is that why the algae's shaking so much? Oh, that's the ostracod shaking it up. Ostracods are interesting because they're heavier than water. So unlike a lot of organisms, oh, damn it! I wanted to capture that image. Unlike a lot of organisms, marine microorganisms, without any motion or help, they'll sink to the bottom. They constantly have to be kicking to stay up. I want to know more about this other guy. Is this Cutie Pie? So this guy is the larval form of... Oops, damn it. I miss it every chance I get. And he's back. Lex, I know. Sometimes I get opinionated. And I can never warn you when a rant is coming. Like, I'll pop off sometimes, Lex. I'm sorry. I wish I could be more reliable. It does sound exhausting, Sarah. It's constant work. Just eat, stay aloft, breed, stay aloft, die. Sounds familiar, doesn't it? Lippersink. Curious how I collect my samples. Do I just scoop some pond water to a jar? Is there a specific way that if I scoop from a pond? It kind of depends on what I'm going after. So, sometimes it depends on the nature of the pond that I'm drawing from too. So I wish you would hold the fuck still. God damn it. I'm gonna have to like take a still from a video that I took. That's my only hope of catching that guy. Anyways, so it depends on what I'm trying to get out of the sample. For example, at this pond where I captured the large Vorticella colonies, let's make another slide of that. That one, I took a scraping because there was all of this, the stuff that I really wanted to look at was growing in tight clumps along the rocky edge of the pond. And so if I just scooped the water, I wouldn't get any of it. So I actually took a stick and I scraped loose a bunch of algae that was growing on the side of the pond. And then using my bare hand, I wafted it up near the surface of the pond. Norman, please don't walk across this. Norman, no, don't get him. He's just going to pass through. My cat is passing through. Yeah, this is my ADD book. I put it here, and it says leave on desk. I have to start trying to do daily journaling. Otherwise, I won't remember to do important things like what I'm supposed to eat for lunch that day so the food doesn't go bad, or remember to do my laundry, shit like that. Like I have to, I don't know. So I'm trying to get more progressive about writing shit down. Whether it's something I need to look up, or something I want to talk about on stream, or something simple like empty the cat box, mow the lawn. Now, sometimes I really need help for basic things like that, and this is my solution. I'm just now starting on this experiment. I hope it works. I wanted to write down. See, I almost forgot to write it down. Spirogyra, algae, reproduction. I wanted to learn what's going on there. Gotta do it. I mean, I do the same thing. Rabbit holes within rabbit holes within rabbit holes. Lex, you can always show him some of my clips, at least.
Little hand says
The
it's
clips
time
are
to rock and
usually
roll.
pretty,
Bring the
hey.
noise.
Marshmallows, thanks for the follow. I appreciate you. Very sweet. I'm going to try to make another sample slide here of these Vorticella colonies. This is, again, Sarah, you're going to freaking love this. Oh, there he goes. Anyways, you're going to love this. In this jar is some of the densest Vorticella colonies that I've ever seen in my life. They're heavy with swan tears, rotifer, all kinds of really interesting creatures are living inside of this. So, I'm going to try to pull. The problem is it's like dealing with a deep marine creature. You know, as soon as I pull it out of the water, the structure and the organism will collapse. So, I have to try to pull just one little piece of this just so delicate structure. It's kind of a nightmare at the bottom of this jar, too. The swan tear videos, yeah. I think so, yeah. The cat's here looking for something to steal. That's all he wants. Swiper, no swiping. Come on, get out of here. Got it. Oh, this is gonna be a big one, guys. And I'm not gonna put this on a cover slip, because that would then ruin the organisms here. Come on, get off of it. Stuck on the tweezer. No. No, this is awful. I'm ruining it. Ah, there we go. Ugh. Oh yeah, check my socials here. This is my follow me on all the socials. I also have a Discord where I'm building a library of my microbes. So if you want to visit my Discord, I've got a microscopy channel on my Discord where I'm just anytime I get a good recording or image of a new creature, I'm building my catalog there. So you're welcome to join us there as well and watch the catalog grow over time. Guys, there are just so many beauties in this jar. I can't even handle it. Let's add more water here. Alright, we're going to abandon this sample. Oh good, the diatom art always makes people feel better. It's really just so beautiful, you know? It really is a beautiful thing, that diatom art. Hang on, I gotta rebuild this surface tension on this side of the slide. Otherwise, we're gonna have a run. Okay. You guys ready to have your minds blown? Sarah, this is some of the coolest shit I've ever seen on my microscope. I wish that I had a lower magnification so that I could show you the larger structures that we're looking at here. It's difficult to really appreciate what you're looking at here. I can see the large structure with the naked eye, but when it comes to what's actually going on in there, it's pretty remarkable. Lipper, followed you Twitter, not really a Discord person, hardly use it. That's cool. No problem. With Twitter, there's some things I'm not going to be able to upload on Twitter just because of the file size limit. Twitter also reduces the quality of the image pretty dramatically, so Discord's the place for the highest quality, largest files. There was a blue strand just now. The blue color could have come from distortion. We are concentrating a lot of visible light right now. Please don't stop. When you concentrate light, sometimes your wavelengths will change a little bit here. Here we go. Ciliates. Vorticella. Lacrimoria. Wasn't that its name? Lacrimaria. Lacrimaria allure. Rotifer, hanging out, just pretending to be Vorticella. Diatoms, caught in massive vortices. These colonies are visible to the naked eye. They're like these wispy white clouds. So what attracted me to this sample, why I drew from this sample, is I noticed something interesting. I was looking at a visible strand of algae. Oh my god, there's so many guys. This is, like I said, this was one of the most impressive samples that I've grabbed yet, if I do say so myself. It was visible. So I noticed that every single strand of algae had a white gelatinous corona around it. Like it looked like a freshwater jelly was nesting at the tip of every strand of algae. Like a broccoli too, though. It looked like a canopy. That's what I scraped up. That's what I took a stick and scraped off the wall of this pond and took it home. And I very carefully sucked up one of those tiny white clouds, and it turned out to be massive Vorticella colonies. What's interesting about these Ooh, crescent diatom. Yes! Cool! These aren't common. I don't see a lot of crescent diatoms. Is that a big-ass stentor? That blue thing. No, I don't keep anything in the jar, and that's what I want to know. I want to find ways to keep these samples alive longer, because it's a challenge. Hey, Snapjaw! Sarah, maybe you can help me. I want to build a home sustainable biome for these things. This is a stentor. Yeah. Yeah, there are swan tears too. Lacrimaria olor, they're called. This thing, I believe, is shining blue, blue-green, because of the presence of cyanobacteria. It's been eating enough algae that the cyanobacteria, breaking down in its digestive system, is tinting it blue. Sarah, let's talk on Discord about it, because I wanted to. It's going to take a more long-form discussion about it. So if you want to DM me or something, because I've got some bubblers to aerate the water. I've got some buckets. I've got some things that I can use to try to make it. But I'd love to build my own home ecosystem that I could farm my own organisms in, and probably seed it. Collect samples and dump it into my home ecosystem to try to seed the environment. I'm okay if I go through some ecological collapses. Rotifer. There's a swan tear. Oh, you know what? You see how the image is shaking? It's because my air conditioner just kicked on, and the breeze is disrupting the surface of the water. Tiny little ripples. So pardon the distortion there. So many things. I know, this is one of the coolest samples I've ever seen. It's really something. So many diatoms. I've seen 3 different kinds of rotifer. Swan tear. Earlier we witnessed cellular mitosis of a heliozoan. Were you in when we did that earlier today? That was one of the coolest things I've also ever recorded. Look at this. Let me show you the video. I couldn't record the whole thing because mitosis takes time. But look at these heliozoans dividing. I'm going to go get a highlight from the oops, I crashed my thing. That clip is too long. I'll go get a highlight from the VOD on that, but it's really cool. We witnessed, there they go, and we witnessed the whole process. It was really, really neat. At a certain point, I don't know if I catch the moment on the clip where they actually break apart, but there's a really great moment. Mitosis, I mean, it doesn't take hours. We watched the very end of mitosis, and it took probably 5-6 minutes for the whole thing to complete. But the point, we started observing mitosis at this stage. So the chromosomes had already divided, they had already duplicated, and gone to their separate new cells. And so at that point, at the point that the cell is actually pinching in the middle and really stretching apart, most of the hard work of mitosis is done. At this point, the membranes simply need to seal off, and then you've got 2 new organisms. Sarah, thank you. I know, extremely lucky. I really just count my lucky stars that we managed to witness that. And it's funny because as we snap to that view, I was just talking about how special it can be to view rare events. How I'm always hoping I'm gonna watch just as this Lacrimaria eats something. I want to watch it eat something. I want to watch this other organism reproduce. We got to see it. And now the rotifer in these samples are behaving differently than rotifer that I've seen in other samples. First, there's 2 different things I'm noticing. Some rotifer are being very stationary. They'll park and they'll just sit there in the colony of Vorticella and happily act like Vorticella. They'll swing their cilia and just suck up, happily be a Vorticella, right? Other rotifer do more typical rotifer behavior where I see them grazing like cattle, where they sort of step and bite and step and bite and step and bite. That's really common rotifer behavior. And then other rotifer in this sample are acting really strangely. They're swimming around like swan tears, where they're stretching out and then just shooting out across the slide and like crashing into algae mounds and then turning around and flying off again, like behaving very differently than I usually see rotifer behaving. It's quite interesting. So many diatoms. There's another rotifer. They're just all over this. We gotta personify things. I put my stream through some emotional, harrowing personification therapy a couple streams back. Yeah, and this is how much water from that sample I've got. Just a tiny amount, but I can look right in here, and there are more of those white clouds. There are so many Vorticella colonies right in here. And this lines every surface of the inside of this pond. This is a really interesting ecosystem because it's one of the only city ponds that have visible crustaceans. Massive, massive crawdads are living in there. Lipper, I'm not a biologist. I am a lay person. I'm just a dude with a microscope and a thirst for knowledge. I love to learn, and I've been doing it my whole life. By trade, I'm a systems administrator. I'm working from home these days, so I sit at this desk for 8 hours a day, 5 days a week, and I help people with their computers. I do troubleshooting, systems administration for Exchange email servers, bit of database management, but just a little bit. File systems management, bit of network security. Crescent diatom, again, another one. I love these things. Nerf the wife. She's saying no. But what do we say to that? Too bad! Sorry, Parm. Here, smell it. It's just a gun. See what I mean? Parm hates guns. Look, even though I just aim it. Sorry, sir. Good boy. He's a good boy. Oh, did somebody give a dog a bone earlier and I didn't do the dog a bone? Do we need to give this dog a bone? Look at this seething mass of life. All in an area less than the size of a head of a pin. And what's neat is they work together very nicely, and they end up creating this maelstrom. Let me see if I can focus on the currents here. I see some organisms moving around. The water's kind of clear, so we're not able to see too much stuff, but uh-oh, here comes some swan tears. You can see all of this stuff getting washed around. Powerful vortices. And when we talk again about the physics of what's happening in the water pressures at play, they're so obvious to see how just this tiny organism, no more than a few microns across, just waving microscopic hairs like this, are able to create intense vortices here. Look at this. Maelstrom is the word for this. These organisms that are able to move on their own sometimes just struggle to escape the pull, especially when they're all working together. And you've got hundreds and thousands of vorticella all waving their cilia at once. It creates a massive vortex. Thank you, Sarah. I'm proud of my vocabulary. I like my vocab. Out of curiosity, does your dog hate it if you aim the Nerf gun at yourself? He hates it if I aim it at myself. He hates it if I pick up a knife. Watch. I'm gonna take this knife. Hey, Parm. You can't even point. I can't even point a knife. He doesn't like things getting like pointed or gestured with. And if we ever roughhouse and wrestle with each other and stuff, he gets very upset. Very upset indeed. Maelstrom is a good word. I forget the name of this little guy. One of my favorite little organisms. It's not a ciliate, it's a flagellate. It moves around with this little thingy up front, coexisting very happily with the swan tear. I don't know why, but I want to turn into Michael Caine. Michael Caine. He gets very upset indeed. She was only 16 years old. Michael Caine talks like this. He gets very nicely. And when he's emotional, he's very emotional indeed. I'm Michael Caine. She was only 16 years old. I stole that from somebody else. That's not my creative content. Don't give me credit for it. I'm not that clever. Sometimes I wish I was. Wish I was a cleverer man. I'm the kind of guy that's not... I can't be funny on my own. I work really well off of other people. I love bouncing funny around. And I can be downright hilarious in the right company, but otherwise, there's that blue stentor again. I wish I could get a better image of you. Blue stentor, how neat. Oh, this one. Oh boy. Oh, you gotta warm up. The arsonist has oddly shaped feet. Toy boat, 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 toy boat. Oh, I lost it on the second to last. Pretty good though, pretty good. It's a tongue twister. Say toy boat 10 times fast. See, you got to 3. It turns into toy boat pretty quick. And then it becomes meaningless. Toy boy. Toy boy, toy boy.
What did you say, Evelyn? Do it again.
Toy boy. It's toy boy. On the second one, it's toy boy. There's 2 crescent diatoms. That's really neat. We're seeing a few of these crescent diatoms. Those are neat. I don't see a lot of those. But what I have not seen any of in this sample so far is gastrotrick, which, as some of you know, is my precious little boy. Gastrotrick is one of my favorite organisms. I think it's the cutest. I want like a gastrotrick plushie or something. Since I don't have a gastrotrick right here to show you, I'll just show you a picture of one. And this isn't chill music, sorry. Thanks, Pretzel, but no. Gastrotrick. Also known as the hairy belly. I just think they're adorable. What is it, Eb?
That thing.
Yeah?
That, when I was over there, it reminded me of the Alolan, what's his name?
Was it a Pokemon?
Yeah, it reminded me of a Pokemon because it, like, you know, it has 3 heads.
Oh, yeah, yeah.
And
That's
yeah,
funny.
it has a big tail.
Lifts up shirt to show his gastro trick. It looks like a centipede. Yeah, kind of does. It's just an interesting organism, and I think it's pretty. They're really charismatic. That's what I love about gastro trick is you watch them and they just swim in these happy little circles, and they're really neat. They look spiky and it's not so fuzzy and soft up close. Yeah. Well, in his like this one, definitely looks a little different, right? My muscle memory starts to take over where I look at a picture like this and I'm trying to turn my dial to focus other images on my computer. I'm like, it's a lot of focus. Let me just fix that here. Wow, guys, I could do this all day. I'm gonna have to stop eventually though. What's that? What is that? Hang on. I don't know. It's not a rotifer. It's too hard. Is it a dinoflagellate? You've seen that before? Is that a dino? Did I just find another freshwater dino? They remind you of horseshoe crabs. Yeah, it does look like that. Here's a dinoflagellate that I managed to view a few days ago. Where is it? It's amazing how some microorganisms have so much resemblance to insects we can see. As above, so below. You'll find a lot of these patterns. The more you study the world around you, the more that you'll find certain similarities, certain structural resemblances as well. Probably related to that, there's a fractal nature to reality, to the universe. Right here, we've got Vorticella, rotifer, something else.
I saw it.
Don't know what this is. Oh, I need to update EDMC too. Hang on, I gotta look up
Get in here right now,
this
Evelyn.
thing. Dinoflagellates. Dinos come in so many different forms. These are very flat, interesting. Looks bulbous from this view, but they're very flat. Okay, so I guess dinoflagellates always have. I mean, that's the one I found, Ceratium, but I don't know if there are other kinds of dinoflagellates. They come in so many different shapes.
Is there a reason the bridge needs to be open?
Let's see. Horseshoe shaped dinoflagellate. No, it's not Ceratium. I might have to ask Microscope Twitter about this one. Because it has certain qualities. I don't see a flagellate there. Dinoflagellates are noteworthy because they have a very visible flagellate or two. And what makes them neat is they don't have, unlike the other organism where we saw it just has the one flagella that it holds out in front, the dinos have one going on its lateral axis and the other coming out of its anterior axis. So it's actually able to turn and maneuver more effectively because it has two axes of thrust rather than just one. Oh yeah! The old Tweedledee and Tweedledum. Absolutely. I got a picture of that thing, so I just wish it would come off of this muck. I want to get a better look at it. Hey, babe. Can I have the thinnest sewing needle that you have, please? I'm going to try to do something I've never tried to do. I'm not going to try to pick one up, but I'm going to try to just move some stuff. The thinnest, absolute thinnest.
Some of them are a little wiggly in here.
Okay.
So just.
You're tiniest guy.
These are all pretty
Yeah, any one of those will do. Yeah, go ahead and pull it out for me. Uh-oh.
simple.
Shit. Pin down. Where'd it go?
Don't move. We're gonna need a magnet.
We're gonna need a magnet. Oh, you're standing on a pipette too. That pin just disappeared, everybody. Oh boy. Oh, you got a magnet. Sweet. Is that that's a kind of rotifer, Sarah? That thing right there? But it seems highly unrotifer-like.
I really need to find this because this is how I got a needle stuck in my toe one time.
Okay, well, let's look. Hang on, we gotta find a pin, everybody.
It didn't roll away.
It could have gone straight into one of the cracks on the wood floor, though. There's no pin here.
Is it in my foot?
Is it in my pants?
Did it roll under your shoe?
No. I heard it hit the ground though, didn't you?
No.
Oh boy. Guys. Chat. The fuck? We're just straight up missing a whole ass pin. Oh look, it's kinda come out on its own now too. Trying to find the name online. Yeah, if you can, Sarah, then we could better identify it. Yeah, it was right here. Yeah, babe, I think it's the borrowers took it. Do you guys remember the borrowers?
Fucking rats.
They weren't rats, they were cute little people. The Hildefolk.
Who were the tiny rats?
The tiny rats?
Yeah.
What tiny rats?
You know, that one with the motorcycle?
Yeah, Stuart Little.
No! Not that little.
Not Stuart
No.
Little. Who was the other one?
Look up.
Ralph. His name was Ralph. Right? The little rat on the motorcycle?
We lost a needle over here, so you need to not be barefoot.
Yeah, just wear shoes. Forever. No more barefoot, ever. Hop up, please.
How?
I don't know.
Evelyn, turn off that song!
Go listen to the same music forever and ever. I don't know, babe. I'll look around here some more.
What if I
Just
get in the vacuum?
don't. Oh, vacuum. I wouldn't vacuum it. All right, let me see here. I'm gonna use a pin. See what happens if I can manipulate what's going on in here. All right, there's my pen.
Full of hair.
I did it. I have seen one of these before. Now that I see its whole form, I've seen this with its kind of uneven. Hang on, let me mute this, guys. All right, unmuted now. Okay.
I didn't even get the area.
You didn't get the area? Oh, get the area. Hang on, mute it. All right. Managed to move the thing. And I do recall seeing it in the past. So I've learned a couple other tricks, so I can freeze frame, and then I can come in here and do a configuration on the settings here too, I think. Right? I don't know what you are. Very cool is what. Oh my god, guys. I've almost spent the last 5 hours exploring these exploring these water samples with you guys. That's a long time. I should probably wrap it up soon.
I was just gonna say.
Yeah, it's time to wrap it up. It's almost 1 o'clock. I started early this morning. We've done a thorough job exploring these slides. We covered a lot of stuff I wanted to talk about. Oh, you sent me a meme? Here. Let me react to this meme here. Here's the bad. Here's the good. Here's the bad that is in the good. Here's the good that is in the bad. Here is life. Here's the person who thought of unskippable ads. I hate advertisements so much. Ads shit in your brain. You found an article about 16 new types of rotifer from Thailand freshwater. Yeah, put a link in there, and then I'll put it up in my Discord too, because I want to share that. That's interesting. Sarah, if you ever find interesting microscope stuff, you can tweet it directly to me anytime you want. You can also DM them to me on Twitch, though I'm way less likely to see that message in good time. And then Discord is also a wonderful way to get in touch with me. For those of you who are just joining and are sad because the stream is ending, there's all my socials. Here's my Discord. These are all ways that you can stay in touch with me or see my content when I'm not live. I'm going to be working on adding these new images to our catalog of microbes on the Discord today. And yeah, keep an eye out. In the future, we'll be doing some gaming. Gotta play my RimWorld game a little more. Oh, good, cool. My Discord's a pretty quiet place. It's not bumping yet, but we'll get there. You gotta give it time. I'm very slowly building this community, and it's been a joy so far, and it's going to continue to be a joy. So I really look forward to future streams with you guys. I don't always sit here and explore my microscope. Sometimes I play mindless video games, and you know, I'll just go play a video game for a few hours, and other times we'll sit around and we'll talk about skepticism or critical reasoning or pseudoscience. I really love, you know, these days we're all stuck inside. We're all highly limited with the degree that we can go out and explore the world around us and experience the world around us. So it's actually, I think it's been very therapeutic using this microscope and using Twitch to share exploring the hidden world that's all around us. So, of course, Sarah, it's been my pleasure. I really look forward to the next time, and thank you so much, everybody that hung out. You guys make it special. You know, if I was sitting here streaming this to nobody, I'd still be having fun. But the degree of enjoyment that we get from each other just heightens the whole experience, don't you think? And in character, I could literally talk and close this out for an hour. So sooner or later, someone's got to push the buttons.
How's that for a slice of
What
fried
the
gold?
hell? Just Sarah? What? Did you... Hang on, let me read. 10 subs?
How's that
What?
for a slice of
Oh
fried
my
gold?
god, Sarah. Holy crap. You're paying for it, a gift you got from Lil Sykes. Oh, Lil Sykes is such a generous person. Oh my god.
How's that for a slice of
Thank
fried
you
gold?
so much, Sarah. Holy crap. Wow. That really means a lot to me. I can't quite put it into words. Holy shit. Thank you
How's
so
that for a
much.
slice of fried gold?
I'm so excited to bring you more of this in the future. Like I said earlier in the stream, we're gonna work on putting together an outside stream, a backyard stream. Not next weekend, maybe the one after, maybe the one after that. We'll
How's
do a
that for
bit
a
of
slice of
backyard
fried
archery,
gold?
a bit of backyard carpentry, and hopefully we can put together a backyard microbiome so that I can grow my own samples and I don't have to go trucking over to the local municipal pond all the
How's
time.
that for a slice of fried
Look, my
gold?
wife's busy, so I'm just gonna give you this one, Lex. A little throwback to when it was just us. Remember Late at Night, Elite Dangerous? See, he doesn't like any kind of harm. Self-harm,
for a slice of
externalized
fried
harm. Okay, shit, harm. Settle down. I gotta put the gun down or else he's gonna keep barking. Alright, guys. Let's take this raid. Let's go raid somebody, because this was an incredible gift,
that for a
Sarah.
slice
You've
of
just
fried
given us
gold?
so much. You've just given me so much. I cannot express. So thank you, thank you, thank you, thank you. I feel like I want to dance about it.
How's that for a slice of fried gold?
Ouch! Ouch! I don't know if you can see that. I just got... Ouch! This is why you have to be careful with your cover slips. Gah!
How's that for a slice of fried gold?
That's not the pin. It's a cover slip. Ouch! Guys, that was so deep in me. Oh, it went
That's what I said last
Baby! Jesus Christ, honey.
Oh, you can't say something like that.
Oh, God. That hurt. It's still hurting. I hope I don't find the pin that way with my feet. Is, Julie still streaming, Sarah? I know her streams are usually kind of short, and I've just done a 5-hour stream, so we might have outlasted her, but, Chat, do you guys know anybody who's out there live right now who deserves a nice, like, what do I got? 10? I don't look at my viewers until I need to know. 10? That's a decent amount. It's probably inaccurate too, but yeah, who can we raid? You've never seen Delmore distressed. Frecht chemist and physicaho. Thank you, babe. Pressure applied.
It's still bleeding a little.
Wait, real quick, let's look at my blood.
What?
You guys want to see some red blood cells? Hang on. Sorry, we were going to end the stream, but now we got to look at some blood. Are there T cells in my blood? Probably not going to be many. I mean, there's always T cells in your blood, but they're not very present unless there's an infection or an invasion of some kind. In that case, then your body kicks the production and T cells come roaring out to attack the threat. Sorry guys, we're taking a quick detour to look at blood cells. Maybe? I don't know if I'll have any T cells in there. I hope I don't see a lot of T cells, because that would mean that my body thinks it's under attack. So, I don't want that. T cells are awesome. I'm not dripping, I'm just oozing.
Okay, well,
I've just got a bit of a leak.
you gotta do it, clean it up right.
I will. Alright, let's look at some blood cells. I actually wanted to ask you to put your blood on, but I actually thought it was rude since I'm ending the stream. No, Nope. Wow, look at it go.
Oh my gosh! Wow! That's all up in your body all the time.
Cool.
It looks so similar to the breast milk.
Look at it flowing. This is the pressure of the cover slip is just slowly crushing the fluid mass of my blood. And it's forcing all of the blood out. You know, it's a liquid, so it's finding the path of least resistance. So that's what we're looking at there is the blood is flowing out to the edge. Let's go back here where it's flowing a little less intense. Like if I come here, this is a full flow. These are my blood cells just sliding along. But let's get back here to where it's a little bit denser. And let's get closer too. We're only at 100 times magnification. So let's go to 250. It's kind of hard to view. Neat. So glad I took that injury at the end of the stream, guys. Now, Evelyn, do you remember if T cells are bigger or smaller than red blood cells? They're bigger than blood cells? I think you're right.
Blood cells are like just little tiny microscopic.
Well, the good news is it doesn't look like I have sickle cell anemia.
It looks so neat. I can see the shape of them like the little donut.
Yeah. So you can see that donut shape is so that an oxygen molecule can fit inside. They literally just carry oxygen like a little bucket.
They carry it all the way, so like sometimes they usually start from like your foot and then they come up to your leg and then thigh and your hip. Then they try to go to your lungs to breathe air.
Yeah, they go to your lungs to pick up fresh oxygen and they carry it all over your body. There's still some flows. I don't see any T cells though, so that's probably good. My body isn't rushing out the defenders for any reason. It's just blood cells. It's all we want to see. White blood cells, those are T cells. Sarah says white blood cells are smaller and only like 1 out of 50 in ratio unless you're injured or have a wound. Yeah, so like I was saying, if I was infected with some kind of bacteria or pathogen, then I would have more white blood cells. But Sarah Holcomb, she's a really fun viewer. She has so much information. She says that normally you only have about 1 in 50 is a white blood cell, and they are smaller. So we probably wouldn't be able to see them because we can just barely make out the individual red blood cells. It would be difficult for us to tell what the white blood cells look like. Very freaking cool, everybody. So, yeah. See, I will bleed for you, chat. I've proven it now. Never let it be questioned whether I will bleed for you, because I have. There's the proof. All right, let's do this raid we were talking about now. What a stream this morning, guys. I've had a huge amount of fun, and I'm looking forward to doing more. If I put a stain on them, then you can see the white blood cells that take up the stain in the whole thing versus the red blood cells. You can see the nucleus. Okay, I only have red stain, so I might need to make a different stain. Can I zoom more? Yeah, let's try one more zoom. Let's go to 1,000 times, because remember, it's a compound microscope, so you've got to do a bit of math, but I only have a 25 times eyepiece, which really limits my my flexibility. Just a minute. Hang on.
Whoa.
So there we are at 1,000 times. Those are my blood cells. And so they've kind of congealed over here on this side. And we're dried up, and they're still flowing in plasma on this side. Let's take a little clip here. So Sarah is saying that if we added some stain or dye, the T cells, the white blood cells, would absorb more dye. And so we'd be able to see more. No worms, no rotifers. My God, what if I found a rotifer? This is where Las Plagas comes out. Look at it flowing around the tension here. Yeah, isn't that neat? Alright guys, I could literally do this all day. We gotta raid somebody. I gotta wrap it up. So we were looking at the names. Scroll up a little bit here. Shit offline. Freaked chemist and physico. Let's just try freaked chemist or frecked chemist, like a freckled chemist. You guys want to keep your learning up today? We'll keep on this educational rant here.
So this one is a scanning electron microscope, and this is a transmission.
Oh yeah, she's talking
electron
about
microscope. I probably
microscopy.
won't say that.
Let's go.
Anyways, so if we zoom 1,000 times more,
This is the stuff that I want to watch
presentation
too.
is only supposed to take me 5 minutes.
All right,
by the way.
go get her,
So
everyone.
We have to
Be kind.
I'm not
Be
giving you
interested in
tutorials
learning,
right now.
interested in growing.
Hell
Pick up as
no.
much information as
I
you
don't
can,
trust you
everybody.
right now.
Let's do this.
Where are the children? They're sitting at home. We're already 20 minutes late. Oh my god, you guys. So if we zoom
All right, thank you so much,
1,000
everyone. I'll
times
see you
more,
later.
we can see that there's these little interesting structures. So what happens is when the light is reflecting off of these interesting little structures, we're actually seeing the colors that are being reflected. And those colors are what we see in this image here. So these beautiful greens, blues, teals, beautiful golden colors.